Good morning, everyone. Good morning. Hope all of you that attended the networking drinks reception yesterday, you had a good time. And you had time to celebrate as well the 20th anniversary of WBA last evening. Thank you to all of you that attended the reception yesterday. So for those of you that just arrived and are here just for today, so I'm Thiago Rodrigues, the CEO of the Wireless Broadband Alliance. A big welcome to all of you to be here on the Wireless Global Congress Las Vegas. We have a fantastic session this morning. And before I jump into the agenda, I just want to give a big thank you to our sponsors that support this event. They have been a big part of WBA and having these platforms for networking and share content between all of us. We'll have, in this morning, we'll talk about mainly 60 GHz spectrum used for unlicensed and Wi-Fi. We'll talk about the next standards with Wi-Fi 7. We talk about AFC, automatic frequency coordination, to be able to use all the capabilities of the 6 GHz spectrum that will be available for unlicensed use. We'll have Kevin Robinson, CEO of Wi-Fi Alliance, Srijan Iyer from Qualcomm, Gabriel Desjardins from Broadcom, Dorothy Stanley representing 802.11 from IEEE, and as well Mark Hamilton from Rutgers Networks. And I want immediately to invite the first speaker of the morning. So Kevin, please come on stage. Big welcome to have you once more on our event.
Thank you. And I was told to make sure I have this the right direction up. Let's see if yes, I passed the test. Okay. So first of all, it's an honor to be here. Thank you, Thiago and team and the members of the Wireless Broadband Alliance. And most importantly, congratulations on your 20th anniversary. So I'm going to spend, actually, you guys go ahead and run the clock. I want to make sure I don't go too far over. Thanks. I guess what I wanted to do during my time up here is focus a bit on how we see the roadmap for 6 gigahertz, and particularly communicating the importance and how critical this spectrum is ultimately going to be for Wi-Fi and ultimately for the broader industry. So for those of you who don't know, I'm Kevin Robinson, the CEO of Wi-Fi Alliance, which is the worldwide network of companies that brought you Wi-Fi. These companies come together with a common vision to connect everyone and everything everywhere, and really focus on driving innovation, but most importantly, industry and market growth through collaboration within the alliance. So very similar to, of course, the work that happens here within the Wireless Broadband Alliance. And I might add that when we talk about collaboration, of course, it is the collaboration of Wi-Fi Alliance members within our organization. But just as important is the collaboration that we have with organizations like WBA, because ultimately it's all of us together that are going to help make this industry as successful as it can possibly be. This is probably not a surprise to anyone that Wi-Fi is an essential component of our everyday lives today. I think most of us, are out of the pandemic rut, but things have not entirely gone back to normal. So Wi-Fi is still the way that people are doing hybrid remote work. It's the way people are doing telehealth. My kids, even today, after all these restrictions have been lifted, are doing regular health checkups, medical appointments remotely, just because it is more efficient for some of the providers that they're dealing with. And of course, those are all many of the use cases that we already have today and have been very entrenched in people's everyday experiences. But there are many emerging use cases that are going to be coming upon us that are going to require strong connectivity from Wi-Fi. Things like immersive experience, AR, VR, industrial IoT. We have new applications around Wi-Fi location, looking forward to potentially what Wi-Fi can do in the areas of sensing. And all of this is going to, again, depend on the capabilities of Wi-Fi. And yes, the high speeds that have always been part of the roadmap. But as I get into some of my materials, I think it's important to see a kind of a fundamental shift within the industry, that we are not just focused on, the number on the box, right? That peak number that people love putting onto the box. It's as important, if not more important, that we focus on the other aspects and capabilities that deliver a better customer experience. And I think a lot of these things were topics of materials and presenters that were up yesterday. So what are we seeing with respect to momentum with 6 gigahertz? It's clearly building around the world. We are now on track to ship roughly 500 million Wi-Fi 6E or 6 gigahertz devices in 2023. And that represents nearly 20% of Wi-Fi 6 shipments. So Wi-Fi 6 is one of the most rapidly adopted generations of Wi-Fi we've seen in our history. And now this year, we're expecting that 6 gigahertz is going to take up a fairly sizable portion of that. And it's important that you don't always compare 6 gigahertz Wi-Fi 6E to, let's say, previous generations of Wi-Fi. It's probably more appropriate to compare our adoption of 6 gigahertz to the adoption of 5 gigahertz, right? Because going from one generation to the next in the same band, we kind of, we know how to do that. We do it every few years, but actually moving into a new band and delivering expectations in that band, that is something that tends to move a little bit slower. So we're very excited to see some of the projections around adoption. The Alliance has certified nearly 1,000 Wi-Fi 6E devices, which again, very, very strong adoption there. But I think probably one of the most important things on this slide has to do with the momentum we're seeing globally. We are now up to more than 60 countries that have decided to open the 6 gigahertz band for Wi-Fi. That's increasing almost every single week. We see very strong adoption in the Americas, and in Europe and in Asia as well. But we still have a long ways to go. So I'm going to talk. This is probably more of the bulk of this, but let's talk a bit about how we unlock the most from 6 gigahertz. And there's 3 kind of key pieces I'm going to be touching on. One, of course, is 6 gigahertz today in Wi-Fi 6E. We'll talk a bit about what's coming with Wi-Fi 7, which, while it does not require 6 gigahertz, certainly access to that spectrum is going to be very important for delivering the optimal experience. And then the ability to deliver standard power. So Wi-Fi 6E unlocks efficiency, coverage, and performance in 6 gigahertz. So some of the more advanced capabilities, of course, are need to support cloud computing, telepresence, and unified communications. I was recently talking to a group of fiber to the home providers, as well as fiber to the room providers in China, so both in Europe and in China. And when you look at what they are trying to achieve in terms of the amount of capacity they're going to deliver to every single home, or in China, a case to every single room, that does not happen without Wi-Fi. So it's great that you have cloud computing, these massive compute resources. It's great that you have high capacity fiber to get it to the home, to the room. All of it is for naught if you cannot ultimately get that connectivity to the end device, and that is where Wi-Fi comes in. So there are some examples here of some Wi-Fi 6E home trials where they reported speeds almost up to 2 gigabits per second in the downlink. Another one by Turk Telecom, where they had, again, connection speeds of about 2 gigabits per second and above with low latency. But then I also want to call it the third one. And this was actually at the Fiber to the Home Council event I was at, where Deutsche Glasfaser, which is a German, focus a little bit more in the rural area, but they're doing major fiber deployments. And they were using 6 gigahertz for backhaul between mesh access points. And they were getting just under 1 gigabit per second for that backhaul link in real world deployments. So some of these scenarios, they were getting, negative 80 dBm on the backhaul link and still getting these type of speeds, right? So this is not in a lab. This is not in optimal conditions. These are in real homes in Germany and what they're seeing with 6 gigahertz. Now, of course, we're going to build on that with Wi-Fi 7, which is going to be the next level of Wi-Fi performance. As with every previous generation of Wi-Fi, the availability of Wi-Fi certified ultimately still serves as a massive inflection point for mass market adoption. And that is not going to be different for Wi-Fi 7. Now, initially, we expect that in 2024, Wi-Fi 7 will be about 2% of all Wi-Fi shipments, but that's expected to grow fairly quickly as after Wi-Fi certified is available. And it's going to offer benefits in terms of extremely high throughput, low latency and jitter, and high reliability. So these are some of the more of the what I would call the theoretical numbers. Obviously, there's going to be people talking about what you're really likely to see in mobile form factors, things like that. But the standard starts getting you into, tens of gigabits per second. Of course, very wide channels, which are only available in 6 gigahertz, that are going to drive some of these throughput gains, and then transmission data rates improvements. But the other thing with the spectrum, and again, we almost can't help ourselves. It's the number on the box. It's the size of the channel widths. Matt hit on this yesterday, and others have hit on this in various events I've been in. We were talking to IFT and the regulator for Mexico while we were in Mexico City. And again, it's great to focus on the wide channels and the performance that provides. But most important for their considerations were around capacity. Because what are they looking at? They have the World Cup coming up. They have to make sure that they're delivering appropriate performance and demanded performance in incredibly demanding environments in stadiums. And so these wide channels, when split up into smaller channels, are ultimately going to give you that necessary capacity. And then, as I mentioned before, Wi-Fi 7, while it definitely benefits from the wider channels offered by 6 gigahertz, it still does bring many improvements to 2.4 and 5 gigahertz. For example, with multi-link operation to provide more deterministic latency, et cetera. All of those things can take advantage of multiple channels or bands in 2.4 and 5. Now, the last piece has to do with standard power operation. And as we're seeing in the United States, in order to use standard power, that relies on the availability of something called automated frequency coordination. And it's very simple, similar to what happens in CBRS, what was supposed to happen in TV white spaces, but is not terribly commercially relevant right now. But where you have access points that are ultimately going into a spectrum access database, determining based on where they are, determining what channels they can operate in, what power levels they can operate at, to ensure that we as an industry are protecting incumbents that are already in the band. Us being good stewards and good that's not a word, being good at sharing spectrum with the incumbents is ultimately what gives us opportunities for future sharing with incumbents. And so this is one of those ways that we are going to protect those incumbents. Now, of course, Wi-Fi Alliance has been really instrumental in moving this forward. We've really made it our mission to support 6 gigahertz innovation and opportunity. And so we've worked very closely with the Wind Forum to deliver the various technical deliverables, both around specifications, testing that will be leveraged by the FCC to ultimately bring products and AFC systems to market. So it's not on this slide, but one of the most recent developments is actually Wind Forum and Wi-Fi Alliance went into the FCC this Monday and essentially gave them the package of finalized deliverables. So you now have the Wind Forum community and the Wi-Fi Alliance community saying, we have done our technical work. It is now, it is ready for the FCC to move forward with the remaining phase of the regulatory approval process, and we expect that to actually happen imminently. So it's a pretty sizable milestone that I think kind of flew under the radar for many people this week, but something that is really going to accelerate us ultimately bringing these standard power devices to market. Now, the final piece that I'll touch on here, and I'll kind of put my other hat on. So Wi-Fi Alliance, of course, a nonprofit industry trade association. When we were looking at the standard power opportunity, we had concerns that ultimately the market was not going to be fully served by AFC operators that were likely to enter the market. So we had many of our members strongly encouraging the alliance to have a more formal role in enabling the rollout of standard power in the US and other regions. And so in order to do that and kind of keep it separate from our primary trade association mission, we established a subsidiary called Wi-Fi Alliance Services that will actually be delivering an AFC service to market participants that it makes sense for. There are going to be multiple AFC operators out there, and vendors, of course, are going to choose the one that makes the most sense for their particular market and their particular needs. But I think Wi-Fi Alliance Services is going to be a good offering for many out in the market. And so, ultimately, our most important concern from the Wi-Fi Alliance perspective is a robust ecosystem and absolutely massive adoption of 6 gigahertz. We want every single Wi-Fi segment to be able to benefit from this new spectrum. So there are some regulatory considerations around 6 gigahertz. First, I think it's important to realize that regulators around the world understand the importance of Wi-Fi. Now, it's still in many cases very much a trade-off with other technologies. They're still going through the decision-making process of how much of the spectrum goes to unlicensed, how much of it goes to IMT. And we are very much in the throes of those discussions. It's a very critical time period we're in right now for the Wi-Fi industry, with WRC 23 coming up in November. I mean, it really is a very critical decision point. This is going to have major long-term implications for the industry. But again, regulators do understand the value of Wi-Fi. And this is one of the ways we've tended to look at it with regulators, which is the economic value. What does Wi-Fi deliver? So back in 2018, we delivered roughly $2 trillion US dollars of economic value. That's expected to grow to just under $5 trillion by 2025. So 150% increase from 2018 to 2025. Part of this is because Wi-Fi is a highly affordable form of connectivity. I often use this term when I talk about one of the greatest benefits of Wi-Fi is delivering affordable performance. There is no other technology out there that has the same combination of capabilities and cost effectiveness. It's why you see Wi-Fi in everything from high-end enterprise access points all the way down to an IoT sensor that you can buy for $8 or something like that, right? And it can span that full set of capabilities, and it's one of the reasons why you see this amount of economic value. Now, ultimately, though, releasing the full 6 gigahertz band would allow us to build on these projections for economic value. The wider channels, of course, provide higher performance, greater efficiency, and just as importantly, a greater frequency reuse to increase capacity in many of those dense deployments. So here's the risk we have. 6 gigahertz is uniquely suited to meet the growing demand for Wi-Fi connectivity. But the critical point is there is no alternative spectrum now or in the future. And this is why the conversations going on right now leading up to WRC 23 are so essential. If we have either we do not get this, as we kind of continue to expand, either don't get this or have slices taken out that ultimately prevent the frequency harmonization that has been so instrumental to the success of Wi-Fi, that could have lasting implications for us as an industry. Too many builds on this one. Okay. The other maybe a little bit more controversial topic, depending on the audience I'm in, is that frankly, IMT networks in the upper part of the 6 gigahertz band are not economically feasible. So we already have countries in all regions that are deploying Wi-Fi in the full 1200 megahertz, particularly in the Americas. And so when you look globally, there's frankly no opportunity for IMT frequency harmonization. It cannot be achieved. And with that market fragmentation, ultimately that's going to prevent the economies of scale that would be necessary for a viable IMT ecosystem in 6 gigahertz. So when you kind of look at all of these investments, billions of dollars to design and produce the cellular chipsets for 6 gigahertz, billions to integrate those into products, billions to deploy the networks, billions to operate the networks. And at the end of the day, billions plus billions plus billions is a lot of money. And it means that really there is an incredible risk for those looking or placing bets on IMT in the 6 gigahertz band, that they're not going to be able to do so in a feasible economic way without a stable regulatory framework that offers them that scale that's ultimately necessary. And then finally, there's the opportunity cost. Again, the reality is there is no 6 gigahertz IMT equipment on the market now or in the near future. Many projections have this, but maybe coming online several years, 5 years, 8 years, 10 years, depending on how optimistic you want to be. Well, there's the opportunity cost. Let's go back to that economic value slide I had. All of that economic value is essentially lost while the spectrum is going unused, whereas the Wi-Fi industry is moving in right away. So, I certainly one could kind of take those comments as having, let's say, a negative view on cellular and 5G. I would probably present it a different way. It's that 6 gigahertz is essential to Wi-Fi, and high performance Wi-Fi ultimately is essential to the success of 5G. We've said it for many years. 5G and Wi-Fi are very strong complements to one another. This is probably a very much an overused slide over the past years, but with each subsequent generation of Wi-Fi, the share of data, each subsequent generation of cellular, the share of data going over Wi-Fi has actually increased, not gone down. When we look at private 5G or private cellular moving into the enterprise, Wi-Fi is ultimately vital to the success there as well. You look at, let's say, private cellular used to deliver coverage and mobility around large facilities. In many cases, a lot of the heavy demand, data demand indoors is still going to be served with Wi-Fi. So it's essential that you have a seamless experience between the two, that you can offload from Wi-Fi, you can move on to cellular when you're actually going to a true mobility scenario. So again, both technologies together are ultimately going to deliver a more consistent, higher performance connectivity fabric. Now, I said earlier that as an industry, we've really tried to move away from highlighting too much the number on the box, the top speeds. And I would say that I am guilty as well. When I put the 40 gigabit per second number up there, I did the exact same thing that I said that we have to do a little bit less of. But again, the reality is we need to be a little bit more focused on improving the user experience and ensuring that experience is good across 5G and Wi-Fi networks. And so this is one particular area where the Wi-Fi Alliance has been working with Wi-Fi certified QoS management to improve that user experience. So what this particular program does is it provides robust service delivery and higher quality experiences for real-time and latency sensitive applications. It allows quality of service end to end, and also the ability to have that quality of service when traversing 5G and Wi-Fi networks. So ultimately, this is going to enable many of those upcoming applications that require that consistency of performance, more determinism that is essential for those applications. And so with that, I want to thank you all for your time and wish you all a great rest of your event.
Thank you, Kevin. I think we can have a few minutes for questions. I have one first question, and then we can open to the audience. There is another one there, so it looks like you did a good job. My first question is about, so you mentioned the transition on migration from the 6 gigahertz spectrum, the evolution and adoption of that band, and you mentioned now the strong evolution on the 6 gigahertz. So you saw that evolution in terms of adoption. Any insights that you can share in terms of type of equipment that has been faster adoption than others, or any specific countries, geographies that somehow are moving faster than others?
Sure, I would say it's very much in line with what we've typically seen with how new Wi-Fi technologies roll out within the industry. So clearly, access points often are the earliest adopters. With that, then we're also seeing 6 gigahertz in laptops, flagship smartphones, right? So that kind of is the vanguard for 6 gigahertz. It's not surprising. It's what we've seen for some time. But now I think you have some newer applications, things like VR headsets, where you could say that's in a way is an extension of laptops or gaming platforms, right? So but that's where we've generally seen it. Now, I think Wi-Fi 6, though, what's interesting with that is we're seeing fairly early on, for example, implementation solutions, let's say, chipsets, reference designs, et cetera, that are targeting the IoT space, and they are already looking to incorporate Wi-Fi 6. I was talking about this at the CSA earlier this week, that was something I think was very encouraging to us, because in many cases, IoT devices have stayed on Wi-Fi 4. And by the way, like one of the first things I did in Wi-Fi Alliance was approved N. That was 15 years ago, right? So it's about time to start moving, right? And it's encouraging to see that.
Yeah, and shows the healthiness of the IoT market as well.
Mm-hmm. Absolutely.
I think there is one question here.
Oh, yeah, it was more because the timer here was moving around. So I was trying to make sure I'm going to be around till about lunchtime. So
thank you.
Kevin, you talked about some trial results on your slide, second or third. So I want to understand what kind of client devices were used when these trials were done, especially the outdoor trial that you talked about, which touched up to 0.8 gigabit. What kind of channel sizes were used? So client devices and channel sizes, which were used in the trial.
Sure. So on the one where I was talking about the mesh, that was not for the access network. Mm-hmm. That was actually being used AP to AP mm-hmm. when they were getting the 0.7 to 0.9 at like minus 80. So those were access points, not clients. But they were pretty standard. I'm not going to say there, but CPE that you would see out there today.
And what kind of channel sizes were used when?
I would need to go back and look at what the.
Okay. Is there a way we can get more details of these trials that were conducted on 6E?
Yeah, and so I think the materials are all going to be made available, right?
Yeah, these materials will be available.
There are links there that will actually show you go to where they go into more detail for each of those scenarios. Okay. The mesh one does not have a link, mm-hmm. but I can get you the detail on that.
Thank
one.
you.
Yeah.
Maria, question.
Thank you. It's great to see the vision that 5G and Wi-Fi are complementary, and the piece of work on course management is a very good, I suppose, a starting point or a step in the right direction. I'm just wondering about the handover, experience, or the seamless experience between the two. And I've made the same point throughout this conference a few times already, which is I don't see enough momentum either in 3GPP or in the actual implementation on either devices or core network components. So is there anything that you think that the Wi-Fi Alliance could do to help with that?
I'm sorry, maybe you just clarify again which transition.
So I'm thinking, 3GPP has done tons of work, okay, with untrusted, trusted, not 3GPP access, and then ATSSS. There are loads of specifications out there. They may or may not be perfect, but the specifications are there. The problem we're seeing is that there are no implementations, either on the device end or the core network end. And it is a catch-22 because the vendors say there is not enough demand, and there isn't enough demand because there isn't enough availability of products out there. So I just don't know if the Wi-Fi Alliance sees themselves as having a role to play in solving that problem.
Well, I think in that area, it's certainly not something that Wi-Fi Alliance is going to accomplish on its own. And I'll use the example of the partnership with WBA in that in general, it's not a hard and fast rule, but we tend to focus much more on, the Wi-Fi device, the over-the-air link. It's really the Wi-Fi implementation. And so I think many of the challenges with providing this experience with cellular requires a lot of the back network, the core network pieces, which frankly, we don't tend to get involved in. And it's very much driven by our members bringing that in. So I guess my answer to that would be the extent to which our members and the industry view that as an important work area and bring it to the alliance, we will deliver it, right? So at the end of the day, it requires some type of market pull and market interest for those problems to get solved. And I think we would also have to solve those in partnership with organizations like WBA, because we're not going to do the full end to end, right? We really try and focus on where our core competency is and delivering that as well as we possibly can.
Yeah, Mary, I'm taking note that WBA can be the bridge between 3GPP and Wi-Fi Alliance, by the way.
There you go. Action taken. Thank you.
Yeah, Rick, there is one question here.
For microphone or?
I can hear you fine. Yeah.
I was interested to hear about the Wi-Fi Alliance service. To commercialize or offer some solution. What else is planned for that?
Right now, it's very specifically focused on AFC. Again, it's our core mission as the Alliance is driving success of Wi-Fi in the market, and this was one area where we viewed a gap, and it really led us to take this role in delivering an AFC service. So at this point, there are no plans to offer anything beyond AFC service through that for-profit entity. If the industry needs us to do other things, we would then look at that. But at this point, it's entirely focused on AFC.
Yeah.
At AFC, America, United States.
Sure. So Wi-Fi Alliance Services Corp, they've, of course, we're one of the conditionally approved operators in the United States. We have also applied in Canada with ISED. And so those are the two right now. We are still evaluating Brazil. We're evaluating South Korea. We actually expect the government's probably going to run the AFC there. So we don't know if there's really a role for private companies or not. And then, so I mean, those are the ones we're really most looking at, but really it's Canada and the US.
By the way, Kevin, I have a question from the online audience.
So absolutely.
Someone asked about what is the status of 6 gigahertz and IFC in the European Union?
You're going to test me on this one.
Yeah.
So obviously, Alex Reutblad, our Director of Regulatory Affairs, is in this every single day. It's, they're still studying the upper portion of the band, right? And I would say there are splits in the EU right now in terms of whether to go IMT. I would say, and I didn't cover it enough. I think one of the points that we've been making more recently that is resonating very well is the sustainability aspect of Wi-Fi. In fact, we're expecting to have a study coming out on that very soon. But when you look at the trade-offs of delivering connectivity, so if most of the consumption of data is in the home, it just logically, now we'll have more built into this, but it just makes sense that a lower power device in the same room or in the same home is going to be far more efficient in delivering connectivity than a macro station that is trying to blast through a stone wall or a concrete wall, right? I almost use the example of it's the difference between a drip irrigation system that's like dripping the water right at the base of the plant versus a huge, lawns are just spraying all over the place on the sidewalk, everything else, right? And that's kind of the analogy I would use with macro coverage to deliver indoor connectivity. And I think that when you look at the goals of many organizations within the EU, they're very receptive to that point.
Okay. Yeah. Thank you. There is one last question.
Just to share some numbers that our colleague asked about test results. In Brazil, we had successfully ran an outdoor testing for Wi-Fi 6E. We achieved 1.9 gig using a Samsung smartphone and near 2 gig using a Lenovo laptop embedded with a 6E chipset. And also another test that we could achieve there was setting up a PTP unlicensed line where we achieved 2.5 gig. So our limitation in that case was the speed test server that the service provider offered to us, but we could achieve that results using commercial products. I need to get back, but I guess it's around 160. I have to get back the configuration. I can share to you.
Yeah,
in many of the cases, because they're doing in the form factor, they're only doing 2 spatial stream on a handset. So they're doing 2 spatial stream, 160 channels and a lot. Yeah.
Yeah. The next speaker will talk more about it. Teresa Nair from Qualcomm is part of the pilot that was developed in Brazil. So she'll share more information with us. Okay, if no more questions, Kevin, thank you so much. A round of applause. Thank you. So that's a perfect transition to the next speaker. So I would like to invite Teresa Nair, Director of Product Management at Qualcomm, to talk about AFC and the final countdown for the services. Welcome.
Thank you very
Thank
much. So we go through the customary check, you know. Oh, there we are. Okay. Okay, so thank you so much for that warm introduction, Diego. Really appreciate it. And congratulations on 20 years. Really, really great achievement. And thank you on behalf of all of us. So good morning, everyone. Hope you're having a fantastic time so far at the conference. I am Shrija Nair, Director of Product Management in the Wireless Infrastructure and Networking Business Unit at Qualcomm, where our team is focused on the technologies for the wired and wireless connectivity solutions for the home, enterprise, and service provider. I am honored to be here to share all the exciting work that's been happening on automated frequency coordination that was referred to multiple times today morning, AFC as we say, and really acknowledge how the industry has come together in record time to deliver a practical solution for 6 gigahertz spectrum sharing. So let's delve right in. As we all know, Wi-Fi standards over the last 20 years or so have evolved from being, just focused on baseline connectivity, moving on to, higher speeds, higher capacity, and of course, latency with Wi-Fi 6. And primarily, we've used 2 frequency bands for this. We've used the 2.4 gigahertz band and the 5 gigahertz band. But, the number of Wi-Fi devices has increased, as Kevin was mentioning, and there are newer use cases that are putting a lot of pressure on higher bandwidths and lower latencies. Add to that, use cases like AR, VR, and gaming, as discussed, are requiring low latency applications. So with all that background, really, the industry came together to champion for and successfully got 1.2 gigahertz of spectrum in the 6 gigahertz band with the US FCC ruling in April 2020, as we all know. Now, this was a historic milestone for us. I think all of us celebrated it, and we've come a long way. With that, of course, the Wi-Fi 6E standard came into being, and we got 160 megahertz of bandwidth in this greenfield 6 gigahertz spectrum, as we say. And now with Wi-Fi 7 that, will be coming up in the next talk, we have 320 megahertz, 320 massive megahertz of bandwidth that we are talking about. And this coupled with features like preamble puncturing really allow you to use that bandwidth around interferences and, ensure that you're using the spectrum much better. So with that, what happens is really the standards have given us protocols and advanced features that are necessary to use the 6 gigahertz band. But when you deploy 6 gigahertz band, there are additional considerations that need to happen. And we've seen this. We've done, the drill with 5 gigahertz, where we took care of incumbents, where we handled the DFS. And similarly, we need to handle incumbents in the 6 gigahertz band. To give you an example, the incumbents vary from region to region or from country to country in the 6 gigahertz band. So in the US and Canada, for example, we have fixed wireless links. And these are operated by your mobile operators, public safety agencies, utility companies, and others. In order to protect these incumbents, a multi-mode regulatory approach, or really a multi-layered regulatory approach, is being defined. Let's take a look as to how this is being done. One of the ways we are doing this is, of course, different countries are releasing different parts of the 6 gigahertz spectrum or authorizing different parts of the spectrum based on how many incumbents are present or how the incumbents are in that region. So that's one way to deal with it. The second way is that we are defining 3 AP device classes, as we may say. And these, again, country to country, they are authorizing it at different points in time. So to tell you, one of the device classes that we're talking of is low power indoor, which is really for, fixed power indoor only. Here, we are looking at a max transmit power of, say, about 30 dBm and typical of about 24 dBm. You're talking of use cases like high-density enterprise networks or indoor residential mesh units, etc. The second class of devices is what we call VLP, or very low power. This is for mobile, indoor, and outdoor applications. Here you're talking of a typical power of, say, about 14 dBm. And really, you're talking, because of this power, you can guess that you're talking of really short-range applications. So think of use cases like in-vehicle entertainment or your AR/VR headsets, etc. And finally, we're talking about standard power, which is for fixed indoor and outdoor applications. Here, we're talking of a typical power of, a max power really of 36 dBm, and use cases that range from, stadiums or rural connectivity and many other such. Now, if you look at it, using VLP and LPI, what we're doing is we are limiting the transmissions to be either indoor or keeping the power lower. And because of this, there is no reason for these devices to know about the incumbents. As a result, these can be deployed easily. LPI and VLP need no information about the incumbents in the area, as they cause no harmful interference to them. But standard power operation, on the other hand, we are transmitting at the highest power, indoor and outdoor. And here, we need information about the incumbents that are present in the 6 gigahertz band. And standard power operation is achieved using a spectrum sharing mechanism called AFC, or automated frequency coordination. But before we go into AFC, we first need to establish really, why do we really need standard power? LPI really brings in a lot of spectrum for indoor and indoor use cases. We spoke about that. But standard power is really needed for 3 key areas, if you see. One, of course, is for outdoor operations. The second is wherever you have connectorized external antennas or weatherproof enclosures. And finally, in all those applications where you need performance, or wherever you have all those use cases in 5 gigahertz where you need higher power. So really parity with 5 gigahertz for those higher power use cases. Examples of standard power use cases beyond the couple that I listed would be, of course, municipalities, campus coverage, stadiums and rural connectivity that I spoke of before, manufacturing plants, or logistics, agriculture, and so many other applications that come to the fore. Now, in some early trials in the US, we are hearing that there is considerable spectrum available in the 6 gigahertz, which allows you to get 80 megahertz and 160 megahertz outdoor possible, which means the gigabit to the home for rural connectivity now becomes a reality with standard power. Also, for the enterprise, in terms of some of the use cases that were possible with 5 gigahertz, in order to make them happen, you need both standard power and LPI. So in a sense, Standard power mode operation is really critical for us to get the maximum performance and to utilize the 6 gigahertz band spectrum in the best possible way. Now that we've established why we need standard power, let us look at AFC and how we achieve it. So AFC is a spectrum sharing mechanism which allows Wi-Fi devices to share the spectrum with incumbents in the 6 gigahertz band. Standard power mode operation via AFC allows Wi-Fi devices to transmit only after they have location-specific information about channel and power. How it does this is really you have an AFC which uses a database lookup system or a database lookup mechanism that has knowledge about the incumbents in a given location. Once this AFC server has this information about the incumbents, it calculates the interference potential versus the frequency and only authorizes Wi-Fi transmission in those channels where you will not have interference or to the incumbents. How this works really is that a Wi-Fi device really needs to connect to a server in the cloud that has information about the incumbents. This operation needs to be done every time the device is activated, relocated, or at least once in a day. Now, the device needs to send information securely. I mean, of course, when you need to send some information securely to the cloud. So you have device credentials that are shared securely to this AFC cloud that we're talking of. And this comprises really of your device ID. I mean, in the US, it'll be your FCC ID. Then you'll have your geographic coordinates because location is critical. And then you'll have what you call the level of uncertainty. And this has to be done at a 95% confidence interval. Once this AFC server has this information, it can get the channel and the power information that the device can transmit at for that location. So extrapolating from all that I said, what we are looking at is really 4 key elements for an end-to-end AFC solution. We're talking of a standard power client. We're talking of a standard power AP with an AFC agent. Then we're talking of a geolocationing piece, for the device to locate itself. And then we have an AFC system with knowledge of incumbents and the device can connect to. Now let's zoom into the standard power client piece that we are talking of. There are 3 types of client categories that have been defined, really. One is we're talking of an indoor client that can only operate indoors and connect to LPI devices. The second is what we call a standard power client or standard client that can connect to standard power APs. And the third is a dual client that can connect to both standard power and LPI APs. You can see from the above that 6 gigahertz standard power for devices and for APs, for clients and APs, really encompasses more than just an AFC system that we talk of sometimes. It needs a lot of elements that need to come together and operate together. Each of these elements needs to be standard-based and interoperable. They need to be, compliance to test specifications. And they also need to pass individual test certifications. So you can see that we are on this AFC journey that involves all these elements coming together. Let's take a look at how AFC or 6 gigahertz really has evolved in terms of a quick timeline view. So we know, we discussed that in April 2020 with the US FCC ruling of, the 1.2 gigahertz of spectrum that was allocated for 6 gigahertz is really when this all started. And many countries after that really have gone on to approve 6 gigahertz in its entirety or partially. If we just zoom into AFC, what has happened is the FCC is really leading the charge, the US FCC. So this timeline view, we'll talk about what's happening with the FCC first. So in November 2021, the FCC asked for proposals from various entities who were interested in becoming AFC operators. 14 such proposals were received by the FCC. Now, this number 14 is super important. The reason is, in the past, when the FCC invited such proposals for TV white space and CBRS, this 14 number is greater than the combined number of proposals it's received in the past first for these two combined. That shows the amount of interest that AFC and 6 gigahertz have, actually. So that's one. And then in November 2022, the FCC really went ahead and gave conditional approvals to 13 AFC operators. So 13 such operators were given conditional approval for operation in the US. Qualcomm is proud to have conditional approval from the US FCC for operation in the US as an AFC operator. Then earlier this year, we had standard power device certification. A KDB was published for that. And that's kicked off, the standard power device testing. And of course, the WFA and WIN Forum in parallel have been working on standardizing the interfaces between the AFC system and the standard power devices. So Kevin spoke about this briefly. And you heard recently, the most recent announcement that Kevin mentioned, technical specifications were really submitted to the FCC recently. So in a sense, what we are saying is there is a lot of activity in the US for AFC. And we hope that standard power device and AFC system approvals happen by the second half of this year based on that. Now, if you look at the global momentum for AFC, and 6 gigahertz, we spoke about, 80 plus countries have gone on to approve 6 gigahertz in its entirety or partially, or are in the process of approving it at this point in time. Now, specifically, if you look at a few countries, where AFC is really active, our neighbor Canada, is looking at, first they approved 1.2 gigahertz of spectrum for VLP and LPI back in back in 2021, early 2021. And then in 2022, they published a consultation on AFC. And now they're inviting proposals from various operators and working through that. So, you heard Kevin mention that as well. So that's pretty active there. Then our other neighbor, Mexico, has gone ahead and published, again, a consultation on AFC. Moving further down to South America, there was a trial done, of course, on 6E outdoor, where Qualcomm partnered with our customer, Cambium Networks, and the National Telecom Agency, Anatel in Brazil, to demonstrate 6 gigahertz outdoor. So we'll talk more about that in the coming slides. And of course, they published a consultation on AFC as well. They're quite bullish on 6 gigahertz. Then if you go to the EMEA region, really, Saudi Arabia was one of the first countries to release 1.2 gigahertz of spectrum for 6 gigahertz. And last year, they had a public demo of, standard power 6 gigahertz AFC outdoor. So lots of activity happening across the globe. And beyond this, we've had consultations, discussions, workshops, really with different countries in the European Union, South Korea, Australia, Japan, Costa Rica, Indonesia, and so many others. Just a lot of momentum around the globe, in summary. If you ask about what we at Qualcomm are really doing for AFC, of course, we were one of the first to provide 6 gigahertz support in our chipsets, but we didn't stop there. We believe that 6 gigahertz is really important, and we are, looking at its adoption across the globe. So, we've been working towards 6 gigahertz standard power operation and how we could evangelize that. So we've gone and built a turnkey end-to-end platform to cloud solution with geolocationing elements that have both silicon and cloud aspects. Now, combining the silicon and cloud aspects really gives our customers provisioning and management ease. The geolocationing piece helps the customers really locate themselves with ease, the devices. And then, of course, the channel and the power information that's that's location dependent can be decoded easily. Because our solution is turnkey, really, our customers can use this to scale it across multiple platforms pretty easily. So that's the other advantage. If you look at it, we have 4 key pillars to our AFC solution. One is a device agent that is required for the secure messaging that I was talking about from the device to the cloud. Then we have a geolocationing piece, which is for locating the device. This has both a hardware element and a software element. So hardware, of course, GNSS-based, and software, we have our homegrown Wi-Fi-based geolocationing solution that we are making affordable and easy to use for our customers. Then we have an AFC service, which is necessary, for connecting to a database of incumbents and getting that information and passing it down to the agent. And then finally, we have cloud management for ease of provisioning and use. Now, all this together is really helping our customers build an AFC turnkey solution for the future so that when the FCC or when the other regulators approve it, they can go ahead and flip the switch and make the transition from LPI to SP. We, of course, are proud, again, to be conditionally approved by the FCC for, as an AFC operator in the US. So we are working with our customers, early adopter customers, to really ensure that we have standard power devices ready for the field. And to give you a quick overview of one of the demos that we did in working with the National Telecom Agency in Brazil and our partner Cambium Networks, we did a 6 gigahertz outdoor standard power demo in Sao Paulo, Brazil. This was the first public 6 gigahertz outdoor demo of its kind in Latin America. So in December 2022, a connection was made available outdoor in Sao Paulo, Brazil, in a municipality of Sao Paulo, Brazil, for about 4 months, where customers could really connect to free Wi-Fi. As you know, Sao Paulo is a very popular tourist country. I mean, I would love to go there. Haven't gone there yet, but love to go there. So tourists coming to the area, restaurant goers, or taxi drivers and others could really come and connect to this free Wi-Fi and enjoy the service and enjoy the experience that it provided. We are grateful to Anatel, who really approved a temporary license for us to do this demo. The trial used Qualcomm chipsets and AFC cloud on Cambium products. So we are looking to really partner with regulators and customers across the globe to demonstrate the value of 6 gigahertz standard power along with AFC and outdoors. This has a lot of impact and can transform municipalities and connectivity in cities, really, as you can see. And finally, just 4 key takeaways from my session today. 6 gigahertz standard power, I think Kevin also mentioned, is really critical for us to use the 6 gigahertz spectrum, maximum utilization of the spectrum, and maximum performance in the 6 gigahertz band. Next generation use cases and the large number of Wi-Fi devices that we have really need 6 gigahertz standard power and LPI. AFC is a spectrum sharing mechanism that allows Wi-Fi devices to share the spectrum with incumbents in the 6 gigahertz band. 6 gigahertz standard power for devices, for clients and access points encompasses more than just an AFC system. You need an end-to-end AFC solution that really comprises of a standard power client, a standard power AP, an AFC service, and of course, a geolocationing piece. We at Qualcomm have been working on an end-to-end turnkey platform-to-cloud AFC solution with silicon and cloud aspects. There is a lot of momentum for 6 gigahertz standard power using AFC and AFC-like systems across the globe. And kudos to the industry for really coming together to drive a practical approach for 6 gigahertz standard spectrum sharing. And we are looking forward to partner with regulators across the globe to bring 6 gigahertz standard power and AFC to the bear, and of course, lay down the infrastructure for next generation use cases. Thank you very much.
Thank you, Srija. If you have questions for Srija, please take note of them, because we are going to have a panel about AFC just in a few minutes. Please bring those questions when we set up the panel on AFC, and Srija will be there participating. Thank you.
Thanks.
Okay, so would like to move on the agenda and invite the next speaker to come on stage. So it's Gabriel Desjardins, Director of Product Marketing at Wireless Connectivity Group at Broadcom, and as well member of the board of WBA. Welcome, Gabe.
Thanks. See you again.
Good to see you.
All right. Hey, everybody. All right. I wanted to talk today about the second generation of Wi-Fi 7. Now, you're probably asking yourselves, what about the first generation? Where is that? Well, it's already out there. You can already buy Wi-Fi 7 devices. It might be a little bit hard to, find them exactly, but, you can go on Amazon. They're already out there. There's, at least a dozen Wi-Fi 7 devices in the market. So that's our first generation. But again, those are high-end devices. Those are expensive. They're a little hard to find on Amazon. We need to do something that brings Wi-Fi 7 to a broader market than that. So first of all, why Wi-Fi 7? It seems like Wi-Fi, after many years of not introducing new technologies, brought in Wi-Fi 6, 4 years ago, Wi-Fi 6E 2 years ago. Why do we need another standard? And I think it's important to go back and look at what we're actually using Wi-Fi for. So in the Wi-Fi 5 days, throughout the 2010s, really Wi-Fi was about video consumption, whether that was watching on TV, watching on your phone, whatever. And Wi-Fi 5 was a pretty good solution for that. Expanded bandwidths, range extension. It was good enough for, kind of receive-only technologies. Now, Wi-Fi 6 coincided pretty well with, a change in how we use Wi-Fi. So video conferencing, was kind of a thing in the Wi-Fi 5 days, but, really, really took off in 2020. And Wi-Fi 6 is a pretty good technology for that. You have a lot of mechanisms to improve latency, prioritize certain applications. Similarly, there's a lot more traffic upload from mobile devices than there used to be. There was really, there was really not a paradigm, 10 years ago. But obviously, we see a lot more of that now, and Wi-Fi 6 is perfect for that. But again, these are the applications of the recent past. What we need now is a mechanism to deliver very high Wi-Fi throughput rates in the home and support new applications like gaming, or we can always cast a hand in the direction of AR, VR, and the tiny sliver of the market that it has right now. So Wi-Fi 7 is perfectly tuned for those new applications going forward the next 5-10 years. So that's why we're introducing a new technology so quickly. All right. One of the other things that happened with Wi-Fi 5 is that because it moved so slowly to a new standard, broadband backhauls exceeded the throughput that you could get out of that technology. And so, that's not a situation we want Wi-Fi to be in anymore. If you're going to be able to get 10 gigabits per second over fiber or cable, which you are very soon in the US, you want your wireless to keep up with that. And Wi-Fi 7 is, perfectly tailored to go and do that. Similarly, we're all talking a lot about 6 gigahertz. There's massive momentum here around opening up the 6 gigahertz band around the world. I mean, aside from China, I think every market of consequence has either done it or is looking at it. And so you need a technology that can take advantage of all that new spectrum. So pulling this together, we have brand new use cases and applications. We have a ton of spectrum, and then we have really fast backhaul that's coming into play. So all that points into a new wireless technology, and that's Wi-Fi 7. I think one of the key things too is that Wi-Fi for years, we always used to say, hey, most people just have an isolated laptop and a router, and there's nothing else going on in their home. So why do we need, any features of consequence in Wi-Fi? Obviously, that's changed. Congested network performance is hugely consequential. We often walk into venues, offices where there's significant number of devices. It's very difficult to get onto legacy networks and get good performance out of them. Even in the home, we have tons of devices now in a way that we did not used to. And so congested performance is of critical importance. So we see a lot of benefits from Wi-Fi 7. A lot of that is around the marquee feature in Wi-Fi 7, which is multi-link operation, which allows a client device to be connected to an access point on multiple bands or connect on multiple channels. So we see an increase in capacity, we see a reduction in latency, we see the introduction of near determinism for applications like AR/VR. And then I guess off in the other corner that we heard a lot about, is AFC. So, huge increase in Wi-Fi range that's coinciding with the launch of Wi-Fi 7, AFC not being a Wi-Fi 7 feature per se. So, we have some actual, visual data here for our multi-link operation latency benefits. You can see as we connect first to 2 different bands and then to 3 different bands, we get massive reduction in latency. Looking off on the right for pretty congested network, you get about a 90% reduction in latency, in your 99th percentile latency using MLO. So there's significant benefits here for a wide variety of applications. Now, like I said, Wi-Fi 7 is actually here. There's a whole pile of different products that have come to market. Most of these you can buy, seen most of them in action. And this is the way, that the Wi-Fi market typically rolls out. The first thing you see in a new technology is very high-end retail routers. And we do expect to see a lot more mobile devices coming out, enterprise routers, but this is usually the first sign of a new market. But critically, there's more to do than roll out this first generation of relatively high-end devices. We need Wi-Fi 7 to be usable in pretty much any residential deployment. So we want to bring Wi-Fi 7 to lower cost mass market access points, mesh networks. Separately, we're seeing huge growth in the IoT space within the enterprise market, so we need to support that. And then similarly, we need to support Wi-Fi 7 in a much broader smartphone market. So it's not good enough to say, hey, you can buy a $3,000 phone or $1,500 phone that has Wi-Fi 7. We need to propagate this down into, where most of the models are, at least in the US. So here's the product ecosystem we have. These are just numbers for no specific purpose here. But you can see we launched in our first generation, a residential access point device, an enterprise access point device, and a mobile device. And these are all, very high-end devices. For our second generation, we've, cut down the top performance, cut down the cost of all these devices. And so we now have a second generation that is more applicable to a broader range of markets. All right, and so a little eye chart here. But I think the key thing is that, we started out first generation 4-stream Wi-Fi 7 access points, 320 megahertz channels, 320 megahertz channels in mobile. That's, again, high end. That is not what the entirety of the market is going to be. And so this second generation of Wi-Fi 7 is really introducing the products that will seed the broader market and that, you will likely get your hands on as this market grows. You see still very high data rates, that can be, roughly match up to the backhaul that you're going to be getting into your homes. Obviously, multi-link operation support for all of these is a critical feature for everything in Wi-Fi 7. And then, you'll see a couple of interesting little notes here, how we're starting to see Zigbee thread support, Bluetooth low energy in access points. The enterprise access point space, this is basically getting to be table stakes. Every Wi-Fi access point for enterprise applications now has support for a variety of IoT applications, whether it's over Bluetooth or it's over one of the other technologies. So this is going to be a critical thing in that market. And then in parallel, we're adding these features on the mobile side. So, you can finally use a mobile device to access Zigbee and Thread networks. To my knowledge, is the first time that this has happened. All right. So talking a little bit more about that IoT ecosystem. So, there has been huge growth in the enterprise space. There are a lot of things in different enterprise verticals, and you need your access point to be able to control them. So, this is why, we've seen growth in these technologies, whether it's Bluetooth Low Energy, Zigbee, or Thread. And, we want to make it as simple as possible with Wi-Fi 7 to also go and service those technologies. So, this is going to show up in factories, in offices, in schools, in any kind of venue, lots of uses in logistics, asset tracking, distance measurements. In parallel, residential IoT, which is a little bit stalled, can finally start incorporating a phone or a tablet into the smart home. You can envision a situation where you have a home control tablet that you sit with in front of the TV, and you turn your lights on or off, or you have something fixed to the wall. And so that's where you have a mobile device essentially operating as the router for an IoT network. And then in parallel, one of the things that we're very big on is next generation Bluetooth technology. One of the key features here is secure distance measurement. This is kind of the holy grail of distance measurement technology. It's something that we saw in UWB, but UWB has not done exceedingly well in the market. So Bluetooth Low Energy is soon going to be introducing a technology that will enable critical use cases like vehicle keyless entry. We're all in on this. You can see lots of posts and videos that we've done around that technology. And I think one of the key things here too is why are all these things important? Like, how did we come up with the requirements for Wi-Fi 7? How do we come up with requirements for our IoT networks? And how do we even decide what was consequential in terms of specs? And I think one of the key things is that Broadcom is really situated throughout the entirety of our networks. So all the way from phones, mobile devices, your in-home equipment, all the way back down through service providers, switching, and into data centers. So we're working to make sure that all of these different elements in the network work together to give you the best possible performance, highest possible throughputs, and best possible user experience. So we like to say that everything is ultimately connected by Broadcom. All right, that's all I had. Thank you very much.
Thank you, Gabe. Any questions from the audience to Gabriel?
Nobody has any questions about this fascinating
I have one, because you brought a new elephant to the room, Wi-Fi 7 generation 1 and generation 2. Can you elaborate a little bit more to the audience, main differences that you guys see from Broadcom perspective?
Sure, absolutely. So, Wi-Fi 7 first generation, I think, is like most first generation Wi-Fi technologies. Very, very high spec bar to clear, reasonably costly devices. What rolls out into the market is, like I said, very high-end retail access points. And so you don't end up necessarily with this massive market. You see the new technology, early adopters pick it up. You may get, some minimal market penetration, but really, the key is to be able to deliver that to a much broader market. With Wi-Fi 6, there were over 1 billion devices in the market 3 years after launch. And, that's the path that we really want to go down. So second generation Wi-Fi 7 is what really enables that kind of massive growth. in the ecosystem.
Yeah, I know that Wi-Fi Alliance is working very heavily on the Wi-Fi 7 certification on the program. I know as well that you guys are already shipping your chipset with Wi-Fi 7. So where do we expect having a full suite of APs and equipment supported by your chipsets on the market available?
I mean, certainly by the end of the year, you'll be able to buy a full Wi-Fi 7 ecosystem for your home.
Okay, thank you.
All right, thanks.
Oh, there is one question. Team up.
Yes. Hey, one quick question specifically about the multi-link operation and its goodness. When, in your view, is a time when it becomes like real world value delivering?
I think that the first meaningful gains out of multi-link operation are going to start showing up early next year. I look at this very similarly to what happened in Wi-Fi 6. Wi-Fi 6 rolled out and it was just a number. It had no features. And it took, 2, 3, 4 years in order to develop really good scheduling technologies on the access point side. I think that the lift is a lot lighter for Wi-Fi 7 than it was for Wi-Fi 6. And so, we're looking at seeing benefits wrung out of this, again, within the next year or even 6 to 9 months.
Okay. Any other question? Okay, if not, Gabriel, thank you so much.
Yeah, thank you.
Thank you for coming. Okay, moving on the agenda, we'd like to invite Dorothy Stanley, 802.11 chair at IEEE and part of the HPE Aruba team. Welcome, Dorothy.
Thank you very much, Tiago, and to everyone here for your kind attention. And I'm honored to be here. I'd like to offer my congratulations to the WBA for all of the good work done over the past 20 years. I remember when WBA was founded, and there were a lot of questions about, okay, what's the role of WBA versus WFA, and et cetera. And I think you've shown clearly that there is a role here, a very important one, between all of the test events and roaming work, et cetera, that really has helped to accelerate the industry. So my congratulations to you. So I'll give some brief, oops, wrong way. Okay, continuing on. Okay, I will give some brief remarks in 3 areas. The first is a summary of our current and new work areas. You've heard a lot about Wi-Fi 7, all the features, et cetera. I'm not going to go over that in any great detail. And then we'll talk about some recently completed amendments that are important to call your attention to, and then connecting the unconnected, which is a topic of great import as much as we talk about serving the high end. There are many, many, many people throughout the globe that still need to be connected. My remarks are mine. They're not the position of the IEEE. So first, a summary of within the IEEE 802.11 working group and 802, overall, what is our focus? Our focus is on the MAC and PHY layers. And you see here that in the context of the entire stack. Why is this important? It's important because we're able to focus just on the MAC PHY or largely on the MAC PHY. And you've seen the improvements that have come out over time. It's also important because we leverage the work that's gone on in the IETF. So TCP/IP, QUIC, all of those technologies work seamlessly in a Wi-Fi network. There's no additional gateway needed, no transposition functions, et cetera. Very seamless. Important because of the seamless use of those upper technologies and because when there are improvements in those upper layer technologies, they come along pretty much for free. Here I want to highlight 2 things. One item within .802 and 802.1, the time-sensitive networking work that's going on in .1, which we're looking at how to leverage within wireless networks. And then secondly, work going on in the IETF at the network and transport layers, where they're looking at improvements in low latency, low loss communication, and active queue management. So a lot of what we've seen in terms of the latency and loss profiles are due to what the upper layer behavior is with TCP/IP and the back-off mechanisms, et cetera. As new adaptation technology is introduced to reduce queuing, we can then benefit from that. So you might want to take a look at RFC 9331 and 9332 for some recent work here. That was 9331 and 9332. Okay. So first I'll focus on the active amendments that are currently under development. There are 5. 11BE is the amendment that defines what's known in the industry as Wi-Fi 7. This standard is largely stable, certainly at the PHY level, right? Always we're discussing potential enhancements or clarifications at the MAC level, but the 11BE standard is largely stable, but we're anticipating that there's still work going on, and we're anticipating that that work will complete in 2024. Additionally, 11BF for WLAN sensing. This is getting a lot more, I would say, visibility, a lot of interest in this area. The idea is, can we use the RF energy that's in a room already being transmitted by a device to offer additional new services in the area of understanding what's in the environment? So we have an amendment looking at that, both in the lower bands, 2.4, 5, and 6, and in 60 gigahertz. 11BH and 11BI, this group is well familiar with the work going on in those two groups. We've had liaisons back and forth from the WBA regarding some applications and use cases that depended upon a fixed MAC address. And so in 11BH, we're looking at how to provide another layer 2 identifier that could be used between an end device and the network or a network application, not the MAC address, and not made visible to the external observer. That's the work there. And I want to call out Mark Hamilton if you have questions there. Mark, if you would raise your hand so everyone knows Mark Hamilton. Mark is the chair of the 11BH task group if you have detailed questions. 11BI is somewhat related, but looking at enhanced data privacy. So we have frames that transit over the wireless medium, and we're looking at the various fields in those frames that could potentially be further hidden or obscured from an external observer. And then 11BK will talk a little bit about ranging and location capabilities within a .11 system. There are numerous technologies out there offering location services, and we'd like to highlight the capabilities that are available in a WLAN system so that the existing network that's providing your data connectivity can also provide location and ranging based services. So, and of course, Wi-Fi 7, the details are here. We won't dwell on those. Okay, so now we'll look at 3 areas of new work. Okay, I've summarized the amendments ongoing. Now we'll look at new work areas. So we know Wi-Fi 6, Wi-Fi 7. What's the logical question? Next question. Right, the next logical question is, well, what's after that? Because we have to start building the underlying technical base that the next amendment will be built upon. And so that's the work going on in the named group UHR, Ultra High Reliability Study Group, that's currently underway, currently active. And so the goal for UHR, you see the little puzzle piece of the baseline. So we take as a given a baseline of longer range, higher throughput, backwards compatibility, and support for positioning. That's a baseline. We have to continue to improve those items. And then on top of that, what is our focus? Our focus is the top puzzle, looking at lower latency, improved manageability, reduced power consumption, a very hot topic these days, given the focus on power efficiency, et cetera. and reduce power usage, and then higher reliability. So the channel that's available to an end user is of higher quality and availability. So this work is well underway. We have an approved what's called project authorization request that's moving through the process of approval within the IEEE Standards Association process. We anticipate that the group will be officially approved as a task group in September of this year, and thus sometime in the late September, early October timeframe, first in-person meeting in November, that we would have a new task group formed here. It will be titled 811BN. It's Bravo Nancy, and it will start work at its first in-person meeting in November. So in parallel with the work that was started here, we also agreed to form another study group called Integrated Millimeter Wave that would begin meeting in November. This group is approved. It's a study group looking at defining the project authorization request, which includes the scope and purpose of another new amendment looking at millimeter wave technology. So now you say, well, you know, Dorothy, we've had 11AD, we've had 11AY. There's been some adoption of that technology, but it hasn't really gone, gangbusters at any level. There are products out there, for example, point-to-point links that support both 60 and 5. Aruba has that, others do, I think, as well. But it really hasn't taken off as much. So the goal of this group is to look at, well, today, our millimeter wave standards have really a unique or largely unique MAC and largely unique PHY. So is there a way that we could more tightly integrate or reuse the mainline MAC and PHY structure to apply on those upper level frequencies to make the implementation simpler? And once the implementation is simpler, then of course the cost profile comes down. So if you're interested in the applications in those upper layers, please participate in this work. Again, it's a matter of, I think Kevin used the word, or one of the other speakers used the word of being good stewards of the technology, of the spectrum that's available to us. And this is part of our continuing work in that regard, so that we can really use and leverage every single piece of license exempt spectrum that's available. Okay, that's UHR. Next group, also currently active. This is a topic interest group on looking at AI/ML. AI/ML, great big buzzword right now, artificial intelligence, machine learning. Our focus here is not on ChatGPT or not on some, vague take over the world technology. We're looking very narrowly at how can this technology leverage and help the performance of a .11 system. There are many operations within the .11 system that are actually quite complex. When you talk about multi-user parameters, as an example, when you're doing MU-MIMO calculations or resource unit allocations to a broad set of users, and how to do that very efficiently and learn from the history and the behavior. And you see a number of the application areas listed here: parameter selection for channel access control, channel usage, BSS transition. So where we're having to analyze a lot of data, are there applications where by making new APIs visible or information visible to a controller or externally to the subsystem itself, or even within the subsystem, can we improve the performance of the overall system? This is currently a topic interest group. They're active through September. And at that time, we may get a proposal for forming a study group. We'll see what the will of the group is. Okay. Final new area is an ambient power study group. This group is looking at forming a new task group that would look into very, very low power operation and all the way to potentially enabling batteryless energy harvesting devices that then communicate over an 802.11 link to an access point or similar. It was very interesting when the topic interest group in this area was first proposed. There was almost disbelief on the part of some that seriously, you could actually, do this and have a system that didn't need a battery? Can you really get a .11 system to operate at such low power? And after many discussions, there was really pretty broad support. We had some prototypes and some demonstrations of some circuits that were basically printed on a cardboard or plastic piece on top of cardboard that were temperature sensors. And they didn't have to deliver or transmit their temperature all the time. It's not like the application needs every 200 milliseconds I have to send what my temperature is. Once a minute is fine. Once every 10 minutes is fine. 5 times a day, perfectly fine, right? So you can have this circuitry that captures energy from the surrounding ecosystem. When it gets enough power, it transmits a frame, right? And then it goes back to sleep and keeps harvesting again. So what does this do? I mean, the potential is to open up a whole new tranche of applications for .11 technology. So you could even envision, say, RFID type systems where you print the client pieces very inexpensively, and you now have a very low cost infrastructure that, guess what, is already providing your data service, your data connectivity service, that could then gather the information from these end devices. So opens up a whole new area of applications. So a lot of interest here. If you're interested in that, I urge you to take a look at some of the documents that have been produced here. All right, so we've talked about amendments under development. We've talked about new work areas. Now we'll talk about 3 or 4 amendments that just very recently completed. And I'll give you the elevator pitch summary on these. The first is 11AZ. 11AZ is next generation positioning. And here, this was completed in end of 2020. It was published in 2023. I'll call your attention to the Wi-Fi Now tutorial that Jonathan Sega of Intel and Roy Want of Google presented at the Brighton, UK Wi-Fi Now conference at the end of May. It's about a 2.5-hour presentation of the gory details of the technology behind 11AZ. But the bottom line is that with that technology, we can get significant performance improvements on the granularity of the level of ranging that you can get with the .11 system. And this enables, again, location and ranging to be provided on the same network with the same RF that's providing your data networking service. So you don't have to deploy different tech networks and manage those different networks to provide the service. Like communications, using a PHY level of light with the .11 MAC and some of the PHY characteristics on top of it. 11BC, Enhanced Broadcast Service. Again, there's a webinar on this and BB to allow uplink broadcast communications. And when you think about IoT applications or potentially these sensors where you want to broadcast to whoever's listening, whichever access points are listening, you now have the protocols to be able to do that. And then 11BD, which looks at enhancements for next generation V2X. So in geographies where DSRC technology is enabled for V2X, particularly Europe, you now have a backwards compatible, higher performance MAC and PHY for that V2X, that set of use cases. All right. In the deck, you'll be able to read this. I want to highlight one item here on 11AZ, which is we typically think about for location applications of wanting to locate end devices, all right? But think back to the presentation on AFC. What was critical for enabling AFC operation? You have to know where the access points are, right? And so now with 11AZ and the prior generation in 802.11 2016, you have a protocol that can be used between access points so that if one access point, let's say, has its GPS coordinate or is configured with its location, now through the 11AZ and Wi-Fi locationing protocols, you can actually automatically have all of the access points determine their location relative to that first one in a very seamless, hands-off way. And this will enable the AFC operation in 6 gigahertz. All right. And then here's the evolution. You see going all the way up to 11 BK. So we get sub 0.1 millimeter at 1 meter accuracy in a .11 system. My timer is counting down. For your interests later, here's an example for 11BC, some of the use cases. Again, this is a relatively new amendment. For operators in particular, I would encourage you to take a look at this. There are probably some applications in the IoT arena or working with, utility companies and similar to support even more IoT applications. And then 11BD. I want to highlight that 11AH 2016, also a completed amendment that works in sub 1 gigahertz, that now is starting to have some market traction. That particularly in Japan, there's been a lot of work here for industrial IoT. And it's good to see some market traction on this standard. And then my final topic was on connecting the unconnected. Here I'd like to highlight some work that's been done by the IEEE, Greater IEEE, together with the Internet Society to expand the education of local village entrepreneurs and deployment of wireless LAN systems, 802.11 wireless LAN systems, paired with backhaul of various types, whether it's Starlink or other satellite or optical fiber connections or what have you, but to provide then internet connectivity to remote local villages. Think about how transformative this is for the deployment of government services, for educational opportunities, for connectivity, for local people to find out more about the broader world, to connect to economic opportunity. The opportunity is simply tremendous. And so it's key for Wi-Fi technology to provide, as Kevin mentioned, low cost, ubiquitous access to the internet and to this technology. It is exceptionally transformative. This is a win-win in so many ways, right? You're taking people who are in these villages, you're training them, you're upskilling them. So now they learn about networking, they learn about wireless technologies. They're empowered and enabled to support the local network, right? Then what does that network provide? It provides learning opportunities, it provides connectivity to the entire village, something that they didn't have before. It enables the rapid deployment of government services, or if there's an emergency situation, you can get medical help or whatever to that environment. You could literally save lives with this. So my hats off to IEEE and ISOC for doing this. What they're doing also as part of this is translating the course that they have into 5 additional local languages. So it's easier for the local people to, get up to speed on the technology. And once talent is so global, right? Talent is everywhere. It's just that a lot of people don't have the opportunity. So think of the opportunity that then is being provided here to these people. So anyway, that's my overage time, Tiago. Thank you for that. And then, of course, we need 120, 1200 megahertz. And we are proud and really honored to develop the underlying technology that provides so much economic benefit and supporting societal development to the broader community. And I'd like to thank all of the hardworking, dedicated engineers who come to 802.11 regularly and participate to develop this technology. So I want to thank you for your time and attention, and thank you, Tiago, for the invitation.
Thank you. Thank you, Dorothy. Any question from anyone to Dorothy? I have one while they decide.
Okay.
You show in the beginning the 5.11 amendments that are in place.
Yes.
Any estimations that you can share in terms of the closure of some of those amendments?
Oh, closing. Okay. Yes, 11BE, I believe, is targeted for the end of 24 for ratification. 11BF, I believe, is also end of 24. They might be into 25. BH and BI, similar time frame. It depends on how they progress. Probably be
P4 2024.
24. I think BH is out for ballot. Probably late 24. And then 11BK. 11BK, since it's built on 11BE, it necessarily must follow BE, depending on the 320 megahertz channel definition. So it will be probably 25.
Okay. Okay. Thank you.
Thank you.
Thank you, Dorothy. Okay, so time now to move to the next session on the agenda. So this panel about building success with 6 gigahertz Wi-Fi, delivering 6E and Wi-Fi 7 with AFC. So I would like to invite Matt McPherson, CTO, wireless CTO at Cisco, Srija Nair, Director of Product Management at Qualcomm, and Mark Hamilton, Director of Networking Standards at Ruckus Networks. So welcome. Once more, thank you for coming back to the stage, Srija. Matt, you spoke yesterday. Mark, big welcome to be here. We heard a lot about Wi-Fi 7, AFC, 6 gigahertz today. I can start maybe with you, Matt. Do you see the 6 gigahertz and the additional spectrum for Wi-Fi as really the big breakthrough for Wi-Fi as a technology?
It's interesting. We talk about the features in 6 and where we came from in 5 and earlier, and we talk about some of the capabilities going into 7. And it was a great, presentation Dorothy just gave. It's always encouraging to see all the development that's going on in the standards. But it all sits on the spectrum. And if we don't increase the spectrum, we can't keep those curves going that we saw on some of the charts that I showed yesterday. So, a lot of people ask me, should I deploy 6E or should I wait for 7?
Yeah.
Well, the answer to that is what's your business need? But it's hard to pick any single feature that means as much as 1200 megahertz.
Yeah. Any comment from Mark? Srija, no? Yeah. So I imagine that's the main reason why there is so much tension about the use of this spectrum. And that's why 3GPP technologies are looking to as well into this use of this spectrum. Maybe we'll start with you, Matt, again. Why do you believe this spectrum is so relevant for these 3GPP technologies, but as well for the .11 technologies? Where do you see that need for all that spectrum? Why all these technologies are seeking that spectrum at the same time? Almost creating that friction that we all know that there is happening today at WRC later today in the year. Why all that tension about that spectrum?
I could repeat what I just said, but but it's look, Cisco's very much involved on both sides of this. We're big advocates of 5G. We're working on 6G. We're big advocates of unlicensed. And obviously, we're very much involved over in IEEE and the WFA and some of the other groups. If I step back for a second and I look at what we're trying to achieve and the amount of bandwidth we need to carry, what we see is that hotspots carry most of it. But at the same time, it's very important that we're able to unify these hotspots together and we can produce a unified experience wherever we are. So look, we have to solve both problems. It's not unusual for me to spend some time with Vodafone or AT&T or some of the other players, and they make a really good case for using, for example, the upper 6 gigahertz band. I presented a case yesterday on what we need to achieve in the hotspots based on that growth as well. My view on this is that the best way to address this going forward is to leverage the incredible investment that's going on indoors. It's often seen as a distributed investment. With the investment that's happening in these ubiquitous type technologies like 5G that have capabilities Wi-Fi doesn't have. You don't go 500 kilometers per hour and expect Wi-Fi to hand off, right?
Yeah.
In fact, last time I was talking to somebody, I said, if there's something moving 500 kilometers per hour indoors, get out of the way. Someone just fired a gun.
Yeah.
So look, we're solving different problems, but if we can pull these things together, and look, we all experience it every day.
Yeah.
I like to talk about a day in the life. I mean, we're all on Wi-Fi when we start at home. You get in the car to go to work and you're all on 5G. You get to work, you go back to Wi-Fi. So if we can make these things work better together, and I think this has to do with how do we leverage the B2B of Wi-Fi? People see Wi-Fi is free. It's not, it's B2B. With what's going on in B2C. And then we can start to converge those networks. I think we can get to common business models. We can achieve what the operators need to achieve in densification because Wi-Fi is already dense. I think we end up in a better place.
Good, thank you. Teresa, you mentioned on your presentation about the standard power trial in Brazil. Anything in terms of insights and results that you can share with the audience about that field trial?
Of course, I think somebody in the audience was, very active in the install as well, and they probably can add more. But really what we saw was we tested with Samsung devices, some Lenovo laptops, and we saw gigabit speeds. In terms of the demo that we did with the National Telecom Agency in Brazil, Anatel, and our partner Cambium Networks and Telium and tech experts who helped us install. So what we saw was, there was enhanced performance. And I spoke about, the use cases that standard power brings to the table in terms of rural connectivity and this dream of gigabit for every home becoming a reality. That possibility was shown in those demos that we had. So, there is the power of transformation that we can have, which we all want, right? When we walk around, we want connectivity wherever we go. So that's the power that brings to the table. So we can talk additionally outside about the results, et cetera, but that's what we did. Thank you.
Thank you. Mark, I know that Ruckus is working quite a lot on AFC as expected. Anything that you can share on the work that you guys are doing and preparing yourselves for AFC and especially for the US market, as is the most advanced AFC industry in the world right now?
Sure. Yeah. As we've heard, the U.S. is leading on the AFC front. Canada following very shortly behind, and then some other countries like Brazil and Korea considering. I guess if I can get in, since you opened the door, a little plug. One of the divisions of CommScope is CommSearch, which has been doing microwave frequency coordination for decades. So we are also launching an AFC system.
You got as well the conditional approval?
I'm sorry?
You got as well, CommSearch got as well the conditional approval from AFC.
Yes, CommSearch also got the conditional approval for an AFC system. And we obviously have access to all the databases of all the microwave coordination we've been doing for a long time. So we'll leverage all of that technology for AFC as well, for anybody who's interested. So yeah, Ruckus is very actively integrating with that CommSearch system and developing that with our access points to deliver 6E standard power capabilities. Really looking forward to Wi-Fi 7. I think the real push for standard power and AFC-based systems we're going to see with Wi-Fi 7. That's when the market technologies will converge kind of simultaneously and come out. So yeah, we're looking for that push and looking for worldwide support from all the vendors and operators to help us promote those standard power technologies in the rest of the world.
Thank you, Mark. Matt, I know that your team works a lot with many regulators across the world. Kevin gave us as well some snapshot of what is happening around the world on AFC. Could you share with us from Cisco perspective how you are involved with other regulators in other regions to accelerate AFC?
Sure. And just a comment on that last question. When I look at higher power, the goodness to higher power is a lot of the attributes that we're talking about: reachability, going through walls, going outside, maybe. The disadvantage to higher power is that it goes further, it goes through walls. So you have this situation where, as you increase power, you increase interference. And so as we start to build these next generation systems where we have these different power ranges that Shrija talked about, what does that mean from interfering with each other? And so when we talk about 1200 megahertz and we talk about how fast we can consume it, the equation changes when we start to do standard power, because that means it's going to create more interference to those that are around you.
Mm-hmm.
And so what are you trying to solve? Are you trying to solve reachability, or are you trying to solve the overall capacity of the system? And it's not unusual when you deploy a new system or you go into new spectrum that you start with reachability because you just want to offer the new service. But as it gets popular, what happens? You start to densify. And so I imagine that we're going to go through a similar sequence as we do this, because it's going to change the radio resource management algorithms. I was at Mall of America not that long ago. I picked up my phone and I looked, I think I could see like 50, 60 SSIDs. Yeah. Right. And that's a problem, right?
Yeah.
Now, what if some of those guys are using directional antennas and what if some of them sign up for standard power? What you're actually doing is increasing the interference.
Yeah.
Right. So there's a lot of work that needs to be done in the industry, I think, as we optimize these types of solutions, and maybe even things like radio resource management has to actually go across what we would consider a rogue to my network, right? So that we can better coordinate some of these spectrum uses. I'm a big advocate. You've heard me talk about determinism, reliability.
Yeah.
All of that stuff is good, but when you start to crowd the spectrum and you start to use higher power, we have to take that into account, and there's going to be best practices around it. Now, as far as working with the regulators, we're really excited because we're seeing a great deal of adoption. The conversations are in the right place. In fact, in some places, I think we had somebody from Brazil commenting earlier, they can't get into standard power fast enough. Right. They want to do the trials and they want to start offering the services. So there's motivation there. And I always think you're at an advantage when the industry is pulling as opposed to you trying to push the next thing. And the industry is pulling this. So we're seeing the right motivations and we're starting to see these things come together. And I think we're going to turn some corners as we go through WRC 23.
Oh, and yesterday, Matt, you shared that graphic that some countries, like 90% of the traffic, IP traffic, is going on fixed access, and many of them on Wi-Fi.
Yeah, I always have to be careful in making statements like that because it makes one technology sound more important than another. And it's not, because we're solving different things.
Correct.
Right.
Correct.
We need both of these technologies. We need them to converge. We need the investment models to be leveraged across both. And I think we can. And that's what organizations like the WBA and others need to achieve.
Yeah.
Tiago, if I could leverage just a little off of Matt's comments. The one thing I did want to point out is there are techniques being put into the standard to manage the power from the clients as well as from the APs. That's coming with all of this stuff that we're doing in 5 gig, let alone 6, with the advances in the recent IEEE standards and Wi-Fi Alliance approved stuff.
Okay.
So the mechanisms are there to deal with those densification situations, control the powers coming from the clients as well. And that's where the AI systems that we've been talking about all week actually start to kick in. And there are in fact mechanisms also being put into the standard to do the cross network communications with each other to help coordinate when we do have those overlapping situations. So not only do we have a lot more channels in 6, which is good, and that helps us with the overlap, but we do have mechanisms on the way. And the AI systems are being considered to manage all that.
Important. Teresa, maybe you presented very well the different power classes, LPI, VLP, standard power. Will you elaborate a little bit for the audience how AFC is going to impact all those different classes?
Yeah, thanks, I think, for that question, Diego. So just, I'll take a step back and just revisit what I said so, audience has context. So I spoke about 3 device classes that are being authorized really for AFC. And as I said, it's all different countries are authorizing it at different points in time. We're talking about 3 classes. One is very low power indoor. As the name suggests, it's for indoor. And, you're talking of fixed power indoor applications where you're transmitting at a lower power, say about a typical power of 24 dBm. The second class was very low power, which is, a typical power of, say, 14 dBm, and for mobile indoor outdoor applications. And we're talking short range applications. And the third category that I listed was standard power, which is really high, where you're transmitting fixed power indoor and outdoor at a max power of 36 dBm. So if you see what we're doing here is, if you look at the power levels that I listed, for LPI and VLP, by keeping the transmission indoor or really just keeping it lower power, we are ensuring that we are not interfering with the incumbents in the 6 gigahertz band. So as such, they do not need to know about, these devices do not need to know about these incumbents. But for standard power devices, for all the use cases that I spoke about, we are transmitting full blast, about this whole getting that range that Matt spoke about, the trade-off that we are making. We're saying, we need higher capacity. We need, this full range of the spectrum. And for that, we need to know about the incumbents in the 6 gigahertz band so that we're not causing harmful interference to them. And as such, we need to have an AFC-like system or with a database where we know about these incumbents to protect them. While for VLP and LPI, there's no need for this AFC-like system, and they can be deployed easily. Which is why you're seeing most countries really go ahead and, authorize LPI soon.
Correct.
So that's what's happening.
Correct. Yeah. And Matt, maybe we can open up between all of us a discussion why these wider channels are so important for the day-to-day of implementing Wi-Fi.
So
the wider channels using the additional spectrum are so relevant. Why? You mentioned that the spectrum is super relevant to the evolution of Wi-Fi, but the ability to have wider spectrum to create different types of channels and have that flexibility from, let's say, a network engineering point of view.
Yeah, I think a lot of times when we talk about spectrum and we talk with the regulators, they're often focused on connectivity to the home. And you get this question, well, do you really need 1200 megahertz, in the home? And but I think that's a somewhat of a limited view. I mean, we all spend a lot of time at home, but we all spend a lot of time at work. And in fact, if you look at the 2 dominant places where we do connectivity, it's at home and it's at work. And at work, typically you're not restricted by your broadband connection, and in fact, they have redundant connections, and whether you're doing SD-WAN and other technologies like that. And so what you really want to do is to densify to increase your overall capacity of the network. And I think I mentioned yesterday, it was very common for our customers originally when they were first putting in Wi-Fi systems to do something that was 5,000, 6,000 square feet. And what we're seeing, it's very common today, is 2,500 or less, sometimes 1,500 square feet. And so what you want to do if you're looking at capacity is to maximize reuse. right? So what you do is you do a channel plan, and most of our customers are doing channel reuse around 6, 12, and maybe higher, 14, 15. You do something like Mobile World Congress, which we do. We use channel reuse more because it's open and the APs are going to interfere with other APs. So a lot about dealing with spectrum has to do with isolating it. You know, that's why we do directional antennas with low apertures, right? And things like that. If we can isolate the spectrum, then we can reuse it over and over and over again. And if we can do that, we can maximize the overall capacity. And we have to do it. I showed some of the charts yesterday on the growth. We have to do this because the demand is there and it's not abating. You know, oftentimes I look at, you know, what are some of these inflection points that are happening in the industry? Well, we all remember when the iPhone was introduced.
Yeah.
Right? It was an inflection point. We changed the way we digitized our lives. It was different. You know, I used to get email off my old phone by doing *74. Now it's telling me, or it just happens automatically. I think this world of AR, and when you see companies like Apple and Samsung and Meta and Microsoft investing billions of dollars into things like augmented reality, it is going to become part of our lives. And we're starting to see that inflection point. So the data requirement is not going to abate. It's going to get higher. It's going to be higher densities, and it's going to have to be done with, maintaining that latency. So how do you do that? You isolate spectrum.
Yeah, I'd like to take one more perspective that I just highlighted about the trials that were done, right? For rural connectivity, if you look at, outdoor, these links that we're talking of, that last mile access, etc., we need those fatter pipes that we're talking of, the 160 megahertz, B320, we never know. But for that, the amount of spectrum that's needed, we need that 1.2 gigahertz of spectrum that's available to make, that gigabit for every home a reality. So while we're looking at, the inside part of indoor homes that, Matt was that focused, we also need to look at the rural connectivity portion. So that 1.2 gigahertz spectrum is going to be invaluable for that.
Yeah, and by the way, I want to just comment on that too, because I think you're spot on. But think about this, you're doing higher power outdoor now so that you can, punch indoors.
Yeah.
Right? All right, now you're punching indoors and you go buy an enterprise business. That's interference to the LPI, right? So are we going to consume 1200 megahertz? We are, because we're going to have mechanisms to avoid each other.
And Matt, you said focus a lot on the enterprise, and you're right, but also even in the home, as we start to get into enough power to punch through walls, especially brick walls and things in Europe, stone walls, we're going to need the power for the backhaul, for the mesh backhaul systems and things within homes. And the homes are close enough to each other that, even in that environment, I'm punching through my neighbor's walls still.
Yeah.
So having, a few channels to choose from, even in the residential, starts to become interesting. And frankly, with AR and VR, with 8K video, we need that 160 megahertz wide for those backhauls, especially. And frankly, in 6 gigahertz with DFS and other issues that are going on, but there really aren't many channels available for that kind of backhaul network in the homes. So it's the densification in the environment, in the enterprise, in the venues, but it's also we're getting more and more dense residential.
Yeah, just a comment about residential. I'm kind of a geek. I don't know about the rest of you, but I've had conversations with my neighbors. Can I configure your AP?
Oh, no, don't say you are a Wi-Fi geek, otherwise they will queue on your door to get help. Any questions from the audience about AFC? There is one from Maria. I never say that I'm a Wi-Fi expert, otherwise all my neighbors will knock on my door.
Thank you. You've all made it very clear during your presentations and the panel that the answer has to be the upper end of the 6 gigahertz bands for Wi-Fi. Understood. However, some countries are considering sharing across Wi-Fi and IMT. And I totally understand the position. However, if that was a decision, I would like to hear your views about how realistic and feasible you believe that is, considering the history of the cellular industry failing effectively to do that sort of thing in a dynamic sense. So I'm very interested to hear your views on how feasible that might be.
Sure, who wants to take that one first? I'm not sure what I would do other than replay some of the same comments that were made earlier this week. Both Mark Giordano and Kevin Robinson touched on those. I would repeat their perspectives. That is it feasible? Of course, new spectrum is something that the IMT based solutions can use, but it's expensive and it's new build out, and it's it's a lift, but it's feasible. Sure. Is it the best use, I think, is the question. And is it where's that balance point and where's that trade-off? And that's exactly why it's the debate that's happening at WRC. It's not a simple question to answer.
Yeah, I'll just say we've had lots of conversations on this, and there's been some proposals like out of UK and other places that maybe we share the upper 700. We do something like that. And when I think about registering spectrum, it has advantages, right? Because if you own the spectrum, you can protect for interference. If you can protect for interference and you can schedule the network, then you can get a very predictable result. So I think there's some merits around that. But I think I have to lean towards the side of worldwide homologation as being such an advantage that architecturally, as we converge these networks together, if we're all working on the same thing, as from a vendor standpoint, it's easier and it's cheaper to make that equipment.
Okay, so with that, I think we can close the panel. Once more, Matt, Lisa, thank you so much, Matt. We'll break now for coffee on the room just on the side, and we'll come back at 11:40 for the next part of the agenda. Thank you, everyone.
Good afternoon, everyone. My name is Al Jenkins. I am the co-chair of WBA's Connected Communities Forum. I'm former deputy commissioner for telecommunications planning in New York City at New York City's Department of IT. And so this afternoon session, or soon to be afternoon session, will be on connecting communities in urban and developing economies. And so we'll talk a little bit today with 4 presentations and 4 panelists to talk about Wi-Fi connecting and the unconnected. We'll talk about leveraging 6 gig enablement, as well as rural Wi-Fi enablement, non-fiber delivery of backhaul smart cities vision. Today we have 4 discussion presentations. The first will be from Mr. Andy Pinley. He's a Senior VP of Wireless Solutions at Zenfi Networks, a Bolden company. Our second presentation will be from Illy de Villiers from Liquid Telecom. She is speaking on digital equity in emerging markets. We'll have a fireside chat with Irvin Guy from DDG in Silicon Labs with the WBA president, Tiago Rodriguez. And our final presentation today will be from Frank Surasi, Senior Advisor in SEP Communications, Cybersecurity Infrastructure Security Agency. And so I'd like to invite our first presentation speaker, Andy Pinley from Zenfi Networks. Welcome, Andy. All right, so this is just going down. Yep.
Good morning. If you guys don't know Al, he has been working in championing equity and working in the government in New York City, where, if you can do it there, you can do it anywhere for many years. And he's a really good chat. If you can't tell, I'm a little bit nervous. Brendan O'Reilly, our CTO, was supposed to do this, and he had a conflict and asked if I could do it. And I was like, sure, it's close to lunch. There's not going to be a lot of people there. The audience would have thinned out by now, and you guys are still showing up. I don't know if it's close to lunchtime, if you guys are hungry, but you're welcome to go get some. But you know, I put a deck together and put bunches of notes with great stats I was going to throw out. And during the break, I came up and talked to Sarah, and I said, oh, you know, is there anything I need to know? And she walked up, she showed me the screen, and I was like, but where's the notes? She's like, there's no notes. So any stat I throw out here is plus or minus 50%. Let's just start with that. So, but it's great to be here, and I'll stumble through this the best I can. So neutral hosts for sustainable and equitable growth. So we're going to talk a little bit about neutral hosts, what they are, how they should be set up for urban environments. We're going to talk about how to build and support sustainable, equitable growth. You know, sustainable is always going to be directly proportionate to profitable when we're talking about 3 Ps. So we're going to talk a little bit about how we can impact the equity areas while building an asset that we can sweat, right? And build a good business case on top of. Next slide. There we go. So, you know, no crazy information here we don't already know. Demand for capacity is going up. We're trying to keep up, and the ability to monetize it by the MNOs is trying harder, but not doing a very good job, right? So that really positions neutral hosts really well, right? Because we can build an asset once and we can sell it many, many times. And this is the right model for the deployment of 5G, not only in urban areas, but across the country. Nobody has enough capital. None of the individual carriers have enough capital to build the dense infrastructure we would need. So, you know, we if you talk to MNOs, a lot of them say, you know, we hate neutral hosts, but they sure do use us a lot. So, you know, we'll talk a little bit more about that. But over the last decade, we've made some progress in getting into equity areas. But the truth is, the gap's widening, right? When you heard Michael talk yesterday about where the fiber is in Las Vegas, it's along the Strip. It's where there's a ton of commercial opportunities for the fiber builders, right? And for the neutral operators to leverage that and sweat that asset. As they move away from the Strip, where there's less commercial opportunity, not a lot of fiber. So you'll see that in big ultra dense networks like New York City as well. So, and it's not always the capacity being there. It also has to be accessible, right? We have to be able to get to the fiber. And we're going to talk a little bit about what we did to sort of overcome that problem. Next slide. So, you know, when I first saw this number, I really wanted to know who the 9% of people were that didn't think we needed mobile coverage. But 91% of people surveyed. We did a survey, a report in 2021. That's Bolden did this survey. And, you know, Bolden's really good at doing some like man on the street surveys. They'll go into, you know, we have one consultant. He literally has traveled across several markets and countries and gone into the subway stations and talked to the people using those transit systems and asked them, what's your problem? What if we did this? Would you like it more? Would this help? What else can we do? So, you know, along that effort, you know, 91% of people think that if you want to be a world-class city, you should have ubiquitous carrier grade broadband access above ground and below ground. And Michael also, by the way, that Michael is one of the best speakers I've ever heard, especially from a municipal speaker at any conference. But, you know, he was talking about that, right? He's like, we want to build this world-class wireless infrastructure, this world-class connectivity. And because we want to diversify our economy, and that's what attracts new businesses. I think this is one of those stats I might be messing up a little bit. 73% of all industry verticals require robust connectivity to relocate or start a business in your city. So this is your fourth utility, and I know I'm preaching to the choir in this room, but it really is. It's just as necessary as being able to provide ample power, or other ample services. Next slide, please. Next slide, but we're going to come back to this one. That's out of order. So, you know, how do we build, as a neutral host provider, what do we have to put in place to be able to build sustainable growth, right? Profitable growth that impacts both our investors, our customers, and the community. Most of the deals we do as neutral host providers, these are deals that range somewhere between 7 to 10 years to 30 years, right? We just entered into a contract with a government agency in New York City. Bolden did is a 30-year contract. So you have to take the long term, and you have to know that you're not going to recover your capital day one. There's not going to be an NRC that covers everything you needed to deploy it. So you have to play the long game. You have to be willing to take 7 years, maybe longer, to start recovering that capital and be a long-term player. And one thing that requires is having really committed financial backers, right? They're not looking for some event horizon over the next couple of years. They're in it for the long play, and they understand that those returns after we recover that capital will justify this investment. They have to be pretty well capitalized too, right? These projects we're talking about are, hundreds of millions and billions of dollars that we're doing. Again, multi-decade commitment to the cities. The franchise in New York City, you have to have a franchise to sell a dirty water dog. So everything you do out in the public requires a franchise, and the deployment of infrastructure is no different. Zenfi is a mobile telecom franchise, so we have the right to put wireless equipment on the city-owned light poles and the utility poles owned by the LEC there. The first one was 15 years. The second MTF is a 10-year commitment, and it's a pretty material amount of money it takes to maintain those franchises every year. So again, we have to have these investors that know it's a long game. We have to be committed to the city for long periods of time to enter into these agreements. We have an agreement that we're going to talk about a little later. That one's 10 years, and we expect it to renew again and go to another 10 years. So these are 20-year assets we're trying to put into the field. We have to be technology agnostic, right? And OEM agnostic, right? So we're big fans of Open RAN, obviously, but going back, we want to make sure every piece of infrastructure we build can support every OEM's radios, can support every carrier's technology. So that's really important. The other thing we want to do is we want to build an asset and create a value proposition where everybody wants to share the same network. And that's the hard part sometimes, right? It might be a little easier in cities where it costs a lot of money to deploy, but I think no matter where it is, that can be the tough part, is convincing mobile network operators and others that it's better to use our shared infrastructure than it is to use a single use. Next. No, back the other way. Yep. Holistic approach to infrastructure. This is, again, I'm going to go through every single one of these bullets one at a time in great detail, but I'm not. But I will pick up a few. But this is the other side of being a great neutral host operator. Everything here is really important. I'll tell you that some maybe are more important to this discussion than others. But one big one is, and I think everybody knows this now, when you go into the city and you're a neutral host operator and you want to deploy all this infrastructure, the city wants something out of it, right? Either they want a rev share, they want something for their constituents, but more than likely than not, they want both, right? So, and this can be a real hindrance for sustainability, especially when we start getting into minimum annual guarantees, MAGs, right? This has tripped up a lot of equity projects across the country. The other is the robust fiber connectivity. So, in wireless, we have some neutral hosts that are only doing siding. So they're going to provide the power and the real estate. But if you look at, especially as far as the benefit to the community, providing that robust fiber connectivity to these siding opportunities, it doesn't just affect the wireless opportunities, right? It creates a ton of connectivity. It boosts economies. FDR said that infrastructure is the bedrock of any economy. I'll go to the next. When we think about the digital divide, areas that don't have broadband access, I think a lot of us think about really rural areas, right? Where the population is, the population density doesn't justify any commercial development. Nobody can get a return on that. And that's what's driving it. But it's not limited there. In New York City, there, you can see the stat here, but the most interesting thing though, that 18%, that's 1.3 million households. I want you to wrap your head around that. 1.3 million households in New York City, the biggest city in the country, has no access to broadband of any kind in their home. Nothing. So when we look at equity and digital equity, when you looked at the programs that came out recently with all these federal dollars, and we went in and we had these plans, this is what we can do in New York City. They're like, no way. Like, we're not even considering starting in New York City. We're going to start in upstate New York. But if you want to look at where we can have the biggest impact immediately, it is dense urban networks. Right now, 50% of all people live in an urban area. And the UN said, there's another one of those, okay, would just plus or minus 50%, that 2/3 of all people would live in a dense urban area by 2050. So could have used those notes. So that's why we started with New York City. We also had a high acumen there. We had a long history there, but it was important to us to start there. People have asked us for years, this is Zenfi, not Bolden. When we were still Zenfi, people asked for years, when are you guys going to expand somewhere else? And we would always say, when we finish with New York City, we'll go somewhere else. But you're never going to get done there. Next. So we're next again. Okay. Nope. There you go. So I've talked about all these ambitions, right? These great things we're going to do, and we know how to do it. But the fact is, we needed an opportunity to do it. So when we started that, we had a legacy fiber company. We sold in 2010. Zenfi was organized on December 31st, 2013, and we won this project in 2014. Keep going back. So the opportunity was, there were 10,000 plus payphones in New York City, and the franchise had expired. Thank you. The franchise had expired for those payphones. So the city had an initiative where they had an RFP, RFI, whatever you want to call it, for somebody to come in and replace the payphones with something that would be a better community service. So lots of people got involved, but the group that won was called City Bridge, and it was a consortium. And it was owned by, quite a few companies, but the biggest players were Qualcomm was a partner there, Intersection, which is an advertising company that at the time was owned by Sidewalk Labs, which was owned by Alphabet. And that's important. And then Civic, who is the ones who developed the structure. So their submission was a 3-meter, 9.5 foot advertising kiosk with a gigabit access point at every one, 2 55-inch LCD displays, free nationwide calling, a tablet with internet access. The displays could be used to monetize for advertising, obviously, but also for city services. It really did serve a big community, a big community need. The other thing is, I think, and this is another one of those stats I had in those notes, in the course of a year, about 98% of all New Yorkers access something with the kiosk. So, and that's not the stat, but I don't know it off the top of my head. It also had a USB port to charge your phone. It has a hearing loop, so for ADA compliance. It was a great structure, and they were going to support this by advertising. And they had some assumptions, right? So this was a payphone replacement project, where I'm going to go way over this time. This was a payphone replacement project where there was an assumption there were these existing conduits from the right of way to these payphone locations. That assumption was wrong, and that's going to be important later. Yeah. So when we went in and, Google was going to provide all the Metro Ethernet, right? So we went into Google and said, we'd like to be your underlying fiber provider. We'll own, operate, and build the fiber network for you. And, at the time we had just started Zenfi. I think we had a ring from like 60 huts and the 32 AVA to 111/8, and that was all we had. And, the other people they were talking to were the LEC or the other obvious player there, Crown and others. But we convinced them that none of those networks would actually work. And we were right. So, what you were going to have to get is, and you guys I'm sure a lot about spectral reuse. Here we were going to have to have a lot of fiber reuse. So if you use a legacy architecture, right, where everything's home into a single location, we have this big ag pop, you would run out of fiber pretty quickly. We're talking about, we only use one, but two pairs of fiber to 10,000 endpoints that we were going to add to the city. So the first thing we did was we worked on what's the right network topology for this, right? So what we wanted to do was build a network of neighborhood networks. So what this did was we wanted really dense, and today this is common. You got to keep in mind, this is 2013, 2014 when it wasn't. We wanted to really densely deploy ag pops, right? And then have a separate network, not necessarily a separate cable, that home back into command and control. So we would aggregate the traffic at these densely deployed ag pops and then come back to command and control. Every time, if I take an 864, right, and I deploy it and I build an ag pop in the middle of it, I now have 1728. Every time I put an ag pop, I double my fiber count. The other problem with the traditional fiber network is because of that network topology, every time you use a fiber, you lose a fiber, right? So no matter where, if I have this 864, we're coming out of a single location, we're running, from Manhattan to Rockaway. When I take two fibers off in Manhattan, I've got fiber stranded all the way from that first location all the way to Rockaway, right? So we had to build a network that literally could not be fragmented. And that's what we came up with. The next problem to solve was accessibility. So in 2014, you would hear pretty commonly, we don't need any more fiber. There's plenty of fiber, there's plenty of capacity. That wasn't true, but people generally thought it was true at the time. But the problem was they were all legacy networks. And it sort of speaks to what I was talking about a minute ago, where, with these legacy networks, where basically what you're doing is we're in New York City, we're using an existing duct system that's owned by the LEC, or no matter what it is, it's controlled by the LEC, whether it's the ECS or in a couple or three of the boroughs, it's directly with Verizon. And it's 99 years old, right? There's literally ducts there made out of wood. So the capacity is diminishing quickly. If you built a traditional fiber network, and every time you wanted to add an endpoint, you had to do an overbuild for that lateral back to your splice cases, which are 3,000 to 5,000 feet apart. It wouldn't work. You would run out of the actual ducting system that you need to run it in. So, and again, people do this now, but at the time, I think we were the only people in the US doing this at any scale. We developed a cable that we had manufactured where we put microducts around all our fiber cables. So we were deploying for our access network. This is to actually reach the endpoints from the ag pops. We're deploying, a cable with 500 plus fibers in the core and then 11 ducts around it, right? So that every time I wanted to drop a lateral off, I didn't have to build back to my splice point. I would just break open the cable. I would couple these ducts together to microduct, and I would blow the fiber into the site, right? This was pretty innovative at the time. We're pretty proud of it. Unfortunately, we didn't try to patent anything, and now it's pretty well used. So we had solved all the problems. Project went off without any problems, right? No. So in 2018, what they found out was this 10,000 site project, they had saturated the advertising market with the first 1,800 sites. The second thing that they had come to realize over the first 4 years, those ducts that were running from the right of way to these payphone locations, they didn't exist. They were crushed. They were inaccessible. They were unusable, and it cost about $200 a foot to replace them. So as you can imagine, the CapEx grew exponentially from what we originally thought it was to what it ended up being. So, the projects, the other problem, we talked about this earlier with the MAGs. So the MAGs were already these are the minimum annual guaranteed rev shares with the city. They were already too high. In late 2019, 2020, there was an event that happened that dropped the advertising revenue. And you guys may be familiar with the pandemic, where there was no more foot traffic in New York City. So, this is another really great thing about Neutral Host. We have long-term annuitized revenue. Our susceptibility to immediacy or, the immediate impacts from the economy turning down is very low. But advertising, no, not so much, right? I have to resell that asset every day. So the program shut down in 2021. Zenfi committed a few $100 million to get the program restarted. But what we said was, you're going to need multiple revenue streams here. You know, the advertising, because it's too susceptible to the economy, this isn't enough. We work with people like Al Jenkins over here. We talked to everybody, and finally we got through a process where we were able to make this investment. And what we got was, we became a partner in City Bridge Wireless. And second, we got all wireless rights. So we immediately started doing what Neutral Host do, which is, how do we monetize this asset? We're going to sweat everything on it. We're going to sell offload on the Wi-Fi network. We're going to find new ways. It still didn't work. And what we needed was a good Neutral Host site, right? I'm not talking about an 80-year-old light pole where we would put a single carrier. I'm talking about technology agnostic, carrier agnostic, a real Neutral Host structure. So what we developed was the Link 5G. We've deployed the first 110 of these in New York City over the last year. We're going to deploy another 2,000 of them. It's a 32-foot structure. It has 5 RF transparent bays. The base of the pole is an 18-inch pipe. In that pipe, we can deploy, we have 4 equipment bays for sub-6 radios. We also still offer all the same city services, slightly bigger footprint. Obviously, vertically, it's a lot bigger, slightly bigger footprint. And we had learned a lot of lessons from the MTF, had done something similar a couple years earlier. We made sure not to shrink wrap this thing so that, I don't know if you know, the MTF decided they were going to let them put 21-inch canisters on top of light poles in 2021. And the next year, Verizon started using Samsung radios that required 22 inches. So we made sure we didn't shrink wrap anything. It's pretty innovative. It's, there's a lot of elegance in the solution from a technology perspective. What's the next evolution, right? So the next is clearly, moving up the stack again, right? Deploying democratized spectrum or even carrier spectrum, but having Neutral Host radios, right? Developing software solutions that give these carriers end-to-end control of their networks across our digital infrastructure. That's the next evolution. And when I heard Michael, I'll reference him again from yesterday, talking about what they had done with the CBRS, that's a great solution. And at the end there were some questions. Somebody asked him one question. He's like, "Yeah, we struggled a little bit." That's a really good fit for a Neutral Host provider, right? We fit seamlessly into that hole. We have an acumen to do this. The other thing is, when he talked about it was hard to expand, the dollars, getting the fiber out, we can monetize it for other things while still providing support to education and create sustainability for the project. This is probably pretty common sense. I think I had a bunch of notes to do a recap, but since I'm so far behind, I'll skip that part. But the fiber adoption is key. I know we all want to talk about the air interface, radios, the RAN, everything else. Getting this fiber out there, getting it into equity communities, it generates so many more opportunities to provide low-cost, equitable access to broadband. That's it.
Thank you, Andy. Very well done. I know we're running a little bit behind, so if anyone has a question for Andy, you can certainly ask it now. If not, we'll move on to our next presenter. Our next presenter is Ellie De Veers from Liquid Telecom, discussing a presentation on digital equity and emerging markets. So please welcome to the stage. Oh, there's a question. All right. So Andy, we have a question for you, I do believe.
Oh, yeah.
Yep.
Yeah, Michael Calabrese. Just quick question is, so for the microduct Neutral Host 5G solution that you outlined, what spectrum are you using? Is that unlicensed spectrum, or does each carrier bring their own spectrum to this?
For the microduct spectrum will be
So it's unlicensed.
Yes, the next step for in going now would be environmental inspection using both GAA and power. And everything think about G, that's a neutral spot. In other words, the carrier can be there with that solution. Think about connectivity, power, cooling, and
Okay. Yeah, no, I've known a lot about Link 5G for many years. I'm just surprised that the mobile carriers they're willing to do their 5G over unlicensed spectrum.
Talking past each other. So the Link 1.0 emissions structure that's 3 meters, right? That's the Wi-Fi, this is public Wi-Fi site. The new site we're doing, the Link 5G that we just started deploying, they're deploying the long spectrum and the long radios inside that.
Okay, thanks.
Thank you, Andy. And now our next presenter, Ellie De Viers from Liquid Telecom, speaking on digital equity in emerging markets. Please welcome Ellie. Hopefully this works.
Okay. So yes, I'm talking today about digital equity and emerging markets. I always find it interesting to come to these conferences because you come here and you hear about the future and where technology is going and how we can collaborate together. And if you think about emerging markets, sometimes there's a perception that they are behind, and it is in fact the case that there are some challenges unique there, which I'll get into in a little bit, particularly around the older devices. But in other ways, it's not so much that emerging markets are behind, but that they're actually just fundamentally different. One of the things about Africa, which is quite well known, is that it sort of leapfrogged in terms of mobile penetration. And so I think it's really interesting to look at emerging markets with this in mind. So what is Liquid Intelligent Technologies? We're formerly known as Liquid Telecom. We rebranded, I think it was last year. So we're a multinational fiber operator. We have over 100,000 kilometers of fiber between the Cape and Cairo, and we're working on the East-West link as well. We're across 16 countries, and there's over 2,000 of us. So our primary business is carrier, wholesale, and enterprise. I suppose I should also say, so my role within Liquid, I'm the group head of affordable access initiatives, which is essentially strategy, product, and partnerships to be able to connect the unconnected. This is a big refrain in Africa, is connecting the unconnected. So I want to talk today about digital equity. So what is digital equity? So those of you who are based in America, it's been in the zeitgeist a lot recently, the Digital Equity Act and with BEAD. And digital equity it's essentially a 3-legged stool, is a good way to think of it. So the first leg is access, without which the other two are not really particularly relevant. And then there's devices and skills. So on the access side, the first question is there access? Is there connectivity? Is there a network there to which people can actually connect? And then what is broadband, right? Like what actually is the definition of broadband? You look at Kenya, for example. Kenya has practically 100% mobile penetration, but only about 40% broadband penetration, right? So there's a long way to go. And again, what are the reasons for this? So costs, availability of the access network, but cost is really a big one. So a lot of the traditional work around connecting the unconnected is focusing on how do you drive down the unit costs. But again, it's challenging. That'll only get you so far. So we have to think a little bit differently in terms of trying to solve the access problem. And then devices. Again, do people have devices? Can they afford devices? And is there power to recharge the devices? So a challenge that some markets, including my former home of South Africa, have is just the whether or not there's actually reliable power. And in many cases, that's not actually the case. And so, underneath connectivity is actually that battery. If your battery isn't charged, it doesn't matter if there's access and you can afford it. So that's a challenge. And then finally, skills. So if you have the other two legs, if there's access, if there's devices, do people know how to use the internet? Do they know how to use it safely? And then also, can businesses find the right skills to be able to actually grow and deliver value-added services or innovative services. So that's digital equity. So some of the things that Liquid is doing around digital equity, so digital skills and education. We're providing low-cost connectivity to innovation hubs in a number of African markets and providing entrepreneur support to some of the organizations out of those hubs with a focus on rural hubs. Because rural connectivity is even more challenging than the urban connectivity. And I think just a general comment in this is the next bullet is talking about that we have partnerships with local ed tech companies to provide hyper-local relevant solutions. I think one truism is that you can't be all things to all people, and you really have to pick and focus what you're good at and where you're going to have partnerships. I mean, we even do this on the access side. We cannot be everywhere ourselves. There's only so much capital in the world. There's opportunity costs. So partnerships are really important. And in particular, that's why the focus on innovation hubs and ed tech companies is both of those. If you provide these kinds of entities with support and services, then they can amplify what they do. And these things are complementary force multipliers in terms of actually getting the impact out there. And then we ourselves have also developed a tech skills program for post-secondary graduates and have trained over 7,000 people so far on things like data analytics, cloud, and AI. So I was mentioning in the previous slide, just basic things when you have people new to the internet about how do you use it? Can you safely conduct things like online banking? Scams are a big problem worldwide, but in particular, a lot of scammers they specifically go after new internet users or people for whom the language of the internet is again mostly predominantly English. And if that's not your first language, using an online service and knowing what is and isn't safe is really hard and makes people targets. So that's one angle. But on the other side, again, there are lots and lots of very well-educated data scientists and computer scientists in Africa as well. So it's important that we not focus on one part of the spectrum without focusing on the other part. So in terms of liquid access initiatives, so schools is a big thing for reasons mentioned earlier, that especially if you have people in primary and secondary school, making sure that those schools have connectivity so that, again, at least the children can come in, the teachers can use it for lesson planning. And if these people don't have internet at home, which in a lot of cases they don't, if at least they have access at school, that's something, right? So it's a very good place to start. So we have connected 5,000 schools, over 5,000 schools already. And it's a lot, yes, but our target is 145,000. So there is a long way to go. And that also shows you just exactly how many schools exist on the continent that are not yet connected. We have connected nearly 2,000 community anchor institutions in South Africa. So things like libraries and municipal buildings. And then I mentioned earlier the importance of partnerships. So one of our key strategies in affordable access is reaching the last mile through partnerships and innovation. So helping smaller ISPs that are actually out there building those access networks, helping them technically, technically in terms of getting the basics right, helping them with the business models, and in particular, helping them with financing, because there's if you have a network working, if you have customers, you have all that basic stuff right, it's still a really big lift for a lot of these smaller companies. They don't understand the basics of financing, and you can only grow so far and so fast if you're relying on organic growth. So that's another thing that we're trying to address. And then aggregation POC plan. So there actually is a surprising amount of Wi-Fi in Africa. But the thing is, it's all these disparate networks. Some of them might be 200 access points, some of them might be 2,000 access points. It's not actually particularly, I shouldn't say it's not useful. I mean, the networks exist, but they have only the very small audiences that they're able to connect to. So one of the things that we're looking to do is to aggregate these things together, and then that would be useful. For example, I mean, we've obviously within WBA, we talk a lot about roaming and connectivity from a service provider standpoint. But again, in Africa, I think a lot of it is like you look at call developed market solutions, and you sort of want to look at them from about a 90-degree angle in Africa. So similar sort of technology solution, and yes, service providers could be a market, but probably a more interesting market is a lot of the apps. Things like, for example, Netflix or Uber or lots and lots of local apps where they have users. And one of the challenges of getting more users is that the users don't have broadband at home and they have a limited budget for airtime. So again, this is one of the ideas of aggregate and provide value, but it's a different approach to the same solution. And so some of our key partners include Microsoft, UNICEF, and the ITU in these initiatives. So public Wi-Fi best practices. What I want to talk about here is just a little bit about what are best practices in the emerging markets to build a public Wi-Fi access network, regardless of business models. You know, it could be that your business model is prepaid, user paid. Could be that it's advertising. It could be that it's a mix of the two. And again, really interesting conversations the last couple of days in presentations about Passpoint, and I've actually been having some conversations literally within the last 12 hours about how do we take this new and emerging. Shouldn't say new and emerging, but again, how do we apply this tool in our toolkit and really just fundamentally rethink some of the ways that we actually look at Wi-Fi access networks to really reduce the user frictions and think a little bit differently. So some best practices for public Wi-Fi is having a clear and researched customer value proposition. I cannot tell you, if anyone wants to hear about silly things that were done with public Wi-Fi in emerging markets, I can talk about that for hours. And one of the most fundamental ones is just having a build it and they will come sort of approach of, oh, okay, well, if we put up Wi-Fi and it's cheaper than the mobile networks, people are going to buy the data bundles. Well, actually, no, right? You have to understand what is the value proposition, because mobile has mobility, right? And Wi-Fi does not. That's the first thing you have to understand. And then there are also real fundamental challenges to, if you're going to have the user pay for it, well, how are you going to take their money? And how are you going to make that safe? And how are you going to make that easy? And how are you going to make that convenient? And so again, you have to understand what's the value you're delivering, and and then make sure that your entire customer journey is really designed for that, right? Because the customer journey doesn't start when the person connects to Wi-Fi. The customer journey starts when they're thinking about, I need to get connected. And if they need to buy access, part of the customer journey is buying that access. And in particular, again, like an assumption you'd have in a developed market is that everyone has credit card, everyone has PayPal. That is not the case in emerging markets, and cash is really king. I mean, even in developed markets, a huge proportion of transactions are over cash. Emerging markets, it's even more so. So figuring out how are you going to get the cash into the system safely, big challenge. So the customer value proposition is important. Put the Wi-Fi where people dwell. This is another one where it's just amazing to me, where people will put up Wi-Fi and they'll have, for example, agents selling it because of the cash challenge I mentioned earlier. And the agent might be a sort of business where people don't dwell. So, you know, your access, you're providing access where people are buying the ability to access your network and not where people are actually going to use it. So I see that one all the time. And then ensuring sufficient density. So again, if people are going to be choosing to buy Wi-Fi or even to opt into an advertising-driven network over their mobile data bundles, you have to make sure that it's worth their while, that the network is actually big enough and interesting enough. You know, if you have 3 access points, who cares, right? They need to be in a discrete area, and the area needs to be where people actually are. And then finally, making sure that people know that the network exists. The interesting thing about Wi-Fi is that it can be there, but unless you're looking for it, then you don't know, right? So yeah, those are some best practices for public Wi-Fi deployments. And then finally, just a couple of implications of all this digital equity in emerging markets. So, so on the access side, does the design of whatever, I'm just thinking particularly about things like websites or mobile apps, but does the design assume users have unlimited bandwidth versus pay as you go? A lot of websites, for example, you know, they in order to load the ads in the website, you load the website and then you have one ad proxy calls another ad proxy calls another ad proxy, and all that consumes bandwidth. And it's fine if you're sitting here and you have unlimited bandwidth, but if you're paying per megabyte and your income is low, it's actually not so great, right? And then does the design presume users have high-speed broadband? Same thing, right? I mean, we all know about people's attention span. If it doesn't load in a couple of seconds, you lose them. Again, not all networks have, because again, really interesting. We're spending a lot of time talking about, especially with Wi-Fi 6 and 6E and 7, talking about what the access layer can do in terms of throughput. And I sort of chuckle to myself because the big challenge in emerging markets is actually the backhaul, right? It's, you know, it doesn't really help if your broadband network, such as it is maybe 5 megabits or anyway. Anyway, and then devices. So how flexible are the low power options on the device side? So that's again, we all just, I mean, I imagine that designers presume that there's easy and regular access to power. Not always the case. And then finally, on the skills and usage side, I mentioned earlier the challenge of the language, the interface being in English, and just making sure that interfaces are, I mean, there are, again, best practices for globalization and localization, just thinking about, can this thing actually be localized to other languages, should that eventually be necessary? And then what's the balance between learnability and usability for, because again, many designs presume, I mean, like, for example, if you think about the settings icon, we all know what that is. If you're new to the internet, you're not going to know what this weird little like hub and spoke icon is, right? So just thinking about some of these things. And then have I considered the safety and onboarding of users who are relatively new to the internet? So again, just some general things or considerations for designing with emerging markets in mind. And that's it. Thank you.
Thank you, Ellie. I'd like to ask the audience if they have any questions for Ellie, but like to pose for her. Ellie, well, then I have one. I'd like to ask you your thoughts on the the governments in the emerging markets in reference to, are they investing in closing the digital equity gap in access, affordability, literacy, or skills, or one or a combination of them all? Do you see any progress with the emerging developing countries in doing so?
Well, that's a really excellent question, because again, back to the three-legged stool, you have access devices. Well, I'm sure people online can hear me. You have access devices and skills. And I think generally speaking, the fundamental challenge is that access. And so in my experience, at least, most of the governments or municipal entities, they're focused on providing access because it's, first of all, it's solving a clear need. It's sort of like hierarchy of needs. You know, if there's no access people can't afford, then you're not so worried about devices and skills. But at the same time, there is definitely a perception or an understanding of, okay, great. So we're funding putting in public Wi-Fi. What next, right? And so what are actually the social problems that we're trying to achieve, and how do we actually do it? So I think the general answer is that the governments are interested, but it is definitely an area of emerging best practice and opportunity for companies or consultants to be able to actually specialize in helping figure out, because a lot of it is really hyper local. Again, if you think about it, because if you're say, so another big thing is jobs and job creation. And so if you're a government, you have two very basic objectives. Number one is provide connectivity. Number two is help people find jobs, right? And so, okay, if you're going to help people find jobs, that's a simple goal, but how do you actually do that? Well, the first thing is you have to understand who are the employers, what do they need, what skills do they need, how can you use the internet to provide that sort of a thing. So, and that's just a very simple example of low-hanging fruit. So I think, yes, there's an area where there's a tremendous amount of work to be done.
It's a good answer. So I look forward to it. Thank you, Ellie.
Thank you.
I'd like next to start the discussion, a fireside chat with Irvin Guy and the CEO of WEA, Tiago Rodriguez. So please, would you both come to the stand? Please welcome Irvin and Tiago.
Thank you, Al.
Yes.
Okay, it's working. Good to see you, Irvin, and welcome. Welcome to Las Vegas and to our Congress. So maybe we can start by just present yourself, present your company, and share with the audience some of the work you are doing right now.
Sure. Thank you. It's good to be here. My name is Irvin Guy. I am responsible for the Wi-Fi product line at Silicon Labs. Silicon Labs, some of you might know, is a leader and focused on solutions for the IoT space. So they focus on Zigbee, Z-Wave, Bluetooth, and my role is how do we branch off in Wi-Fi and leverage that for IoT, but also multi-protocol Wi-Fi, so it works with the other technologies and the intersection with Matter.
With her.
Fantastic. Maybe we can start this discussion just by, as you work so much on IoT, what are the key trends that you see coming from the market that are shaping the IoT industry? Because there's been a drastic acceleration on the IoT adoption all worldwide across multiple use cases.
Thank you. IoT is a very broad term, and it's a very fragmented market. But if you were to generalize, there's at least 4 trends that kind of transcend the different segments. One is, even if we just take a look at our personal lives and take a look at the home and the enterprise space, we have a lot of connected devices. That means there's a large install base of devices that's already out there. And then with the fact that the edge to cloud compute model that is available, the IoT devices are in a very unique position in the sense that they can continuously update any changes in usage patterns, in the conditions that they're surrounded with, which is the opportunity in IoT. In addition to always refreshing the hardware, the new features, and selling those devices, there can be an additional revenue stream in which, given this technology, you can update with new features, or you can also do predictive maintenance of the device itself. So that's another structure that people are now leveraging, to keep the customer satisfied, but at the same time generate more revenue based on the install base. Security is always in the news these days. That's another big thing. So from a Silicon Labs perspective, we start working very early with the customer base, like right during the design stage. We have what we call custom part manufacturing service. But in a very simple term, what that does is you have like a root of trust at a chip level. And you can then extend that to the device over the life of the device. Regardless of what the location is, that there's a ability to authenticate it. And that we integrate with our secure Vault technology, and we leverage that as well. The other one that everyone talks about these days is AI ML. Given the fact that these devices are connected with Wi-Fi, they have usually a small processor, a ARM MCU in it, and they tend to be low power. They go into areas where many other devices might not be. So that allows the algorithms to retrain the models, to evaluate the performance, and in many cases actually make intelligent predictions, which is then leveraged by AI ML for that space. And then finally, you have to be low power.
Yeah.
When we're talking, I really liked the presentation from the previous speaker, Ella, when she talks, she was chuckling when she heard all the discussion on Wi-Fi 6E and 7. Even in IoT, sometimes it is really that, hey, it has to be low power and you have to have multi-protocol support. Because since it's so fragmented, you're going to have Z-Wave, Zigbee, Bluetooth out there. How do you solve that at a device architecture level? So there's a lot of thought, intelligence that goes in to keep the power low, to keep the cost low. That also gives an opportunity to the silicon guys. So,
And Erwin, do you see the trend that Wi-Fi technology is evolving to deliver specific requirements and capabilities for IoT? We started to see it with Wi-Fi 6 with the target wake time capabilities. So you see that as a trend that Wi-Fi capabilities needs to bring more IoT requirements into the specifications and the capabilities.
Yes, definitely. There's a couple key trends. I think, Tiago, you already hit on one of the key ones. Given the fact, like I said at the start, that we have such a large installed base of devices in the home, in the enterprise, all that leads to congestion. And then if you go back and take a look at what's out there installed, many of these IoT devices are still Wi-Fi 4. So the bigger trend that we're seeing right now is a transition to Wi-Fi 6 for the features that you highlighted. The WBA in your IoT work has been driving many of these features. The WFA under Kevin and the team's leadership is doing the same. There's certifications for IoT. So the trends we see are transition to single band Wi-Fi 6 and followed with dual band for 5G. But the other trend we see is there's so many different applications in IoT. If you have something, for example, for the home or a wearable or a medical, many people don't realize medical devices are one of the largest growth segments within IoT. Over there, if you have a wearable device, you want it to be self-contained, low power. It might be a SoC. But then if you're looking at the enterprise and you're look at something like smart grids, grid automation is big business right now, just from that standpoint. Over there is so much fragmentation on the software, the operating systems that are running from different MCUs. Then the Wi-Fi architecture has to be done as what we call an NCP, an attached model. So you really customize it based on those segments.
Many use cases on IoT have that particular use case that the lifetime duration many times is very long periods. So we need to plan for that.
Yes.
In terms of battery capacity and the maintenance of those devices, and many times doesn't happen in other use cases, more focused on the broadband access.
Yeah, and many times they have to be installed, and it's a good thing, like we indicated earlier, that they can be continuously maintained with new functionality, new features. So you definitely have to leave some of that headroom over there. And battery life, we're talking a couple of years, 3 years. So definitely a much longer cycle.
Correct. We saw this morning a lot of discussions about additional spectrum, 6 gigahertz, Wi-Fi 7 coming. So is there an evolution as well on the other standards for IoT?
I mean, unlicensed spectrum for Wi-Fi is always a good thing. I'm a big proponent for that. And at Silicon Labs, we also work, for example, with the WFA on how we take Wi-Fi 7 forward for IoT certification, because we do have to fit in certain power profiles and cost budgets from that standpoint. But the other big trend, of course, is the Wi-Fi 6. How do we leverage that target wait time, those functionalities, incorporate that, and then differentiate by getting that Wi-Fi to coexist with different protocols to make sure it does fit that low power? Because when you're deploying these devices, not only have they got to be in the market for a longer time cycle, but they also have to be able to connect to devices that already are out there.
Correct.
Yeah.
Right. Yeah. Good. You mentioned Matter. So there is a lot of success and increased adoption. How is the intersection with Wi-Fi and that collaboration between those technologies?
So Matter actually has been a very positive development for the IoT space, maybe more so for the home version of the IoT market versus the enterprise, for a very simple reason. There are so many people wanting to control that platform in the home. You have Amazon, you have Google, Samsung, Apple. You even have device players like TP-Link that want to be in the home, which is great. There's a lot of choices for the consumer, for the user. But the challenge that creates is there's a fragmentation on which devices will work with each other. I mean, the easiest example is, if you buy a light bulb from one vendor, it might need the hub of that vendor to work. And how many hubs are you gonna, stack up in your home? With Matter, there is that advantage that devices cross-work with each other. And that makes the consumer's life easier because they know that if they bring this in from different vendors, they will work together. It also is good for the industry as a whole because when people are not concerned if they're buying the right product, they are more flexible in going out and being early adopters. So it lifts every tide, I believe. Yeah.
Good. Yesterday, we heard so much about AI on the Wi-Fi space to optimize networks, optimize device management, optimize channel management. Your insights on AI, machine learning capabilities into this IoT market?
Yeah, I mean, we always have to be careful how much of it is hype. We always go through these cycles. But I think in AI and ML, because they've been training models, it's been there already for the IoT space. And there's a very simple reason for it. It was practical. Because when you are creating an optimized device that has to save power, it has to have long battery life, you already were getting very creative in figuring out how you could increase your chances of those devices. And given the fact that you have sensing on the edge, it's an excellent capability. So companies like Silicon Labs, we've already been incorporating it. For example, if we have a SoC, we'll have Wi-Fi 6. We will also have a M33 from a processing capability in it. But we also put in dedicated hardware accelerators for a very simple reason, because they have already been power optimized. Just for AI functionality, like we're talking about, it's 6x lower power than using a general purpose processor to do it. And not only is it good for the consumer, because you are getting applications, for example, let's just pick retail. It doesn't take much from a computational power to do people counting. And you can do that on the edge in a device that is so small as like one of our devices, and take away from the need to send everything to the cloud, where it's a lot more expensive to process the video and then get the data back. And what is it used for? I mean, many people associate IoT with retail shelf tags, for example. But think about it. Given the fact that you can have these battery-powered cameras, they can actually see the foot traffic, how many people, is it moving left or right? And in some cases, customers also take a look at how much inventory is left there on the shelf. So all these devices can be done over here. In the enterprise, an example would be anomaly detection. For example, if the air quality is changing, that can be done on an IoT device like this. We also have customers that use our building blocks to do audio pattern detection. If there's a glass breaking, that can mean a certain thing. How do you take action on that? So a lot of this can be done by sensing and leveraging the AI to do it on the edge, and then as needed, use maybe external MCUs or the cloud to take further action. So it's been there. There's more and more applications being leveraged.
Erwin, you mentioned two use cases: retail, industrial. Any other cases that you'd like to share with the audience where AI, machine learning capabilities are really making a difference?
Many people are familiar with doorbells in the home. Now, there's many false positives that come from a doorbell, from a camera. It doesn't need very sophisticated high-resolution image processing. But at the endpoint, the device that's sitting on it can be trained on which model makes sense and when it should be an alert. So, so it's not really enterprise, retail, it's home. There's multiple use cases. And the good thing is that we just provide the building blocks and the training model, but the customer base is so intelligent that they're thinking up new applications to build on top of that. So,
thank you. I don't know if there is any question from the audience for anyone. There is one.
I'd like to get your point of view on Halo, what the interface is being for Halo, and what's the road to adoption yet another standard.
So I might be biased in my answer on this one, because we focus, and I focus a lot more on low power Wi-Fi. And the advantage of that has been, it already fits into the overall infrastructure that's out there. And Halo is one more standard on top of what's out there that's available. Some of the applications that customers evaluate, like, for example, a solution for us or a Halo-based solution would be if in farming that you wanted to send something over a certain distance with very low data point, which one is better? But then when you take a look at the commercial metrics, and the module cost between one and the other, it doesn't add up. Over time, will it? Perhaps. I think there's a lot of potential in that technology, but there is already so much effort and energy, no pun intended, on low power Wi-Fi that I think it's an easier sell and adoption. So.
Any other question? Erwin, what's coming next on this IoT space?
I think we already touched upon a few of the points that you actually brought up. I think the Wi-Fi is pretty straightforward. You are going to have a transition to Wi-Fi 6. I don't see 6E. I see a path towards Wi-Fi 7, just because so much more work is being done on the IoT certification of that standard. And then I think with AI and ML, you're going to see more SoC architectures getting sophisticated on this. And the partitioning between what's done in the endpoint for IoT and the cloud will shift as more applications become available. It's very exciting when we talk to customers, because the applications that are coming up on these devices are across geographies. We have emerging market customers that are solving a completely different problem. In that case, they might not necessarily have the wired infrastructure in place to plug the device in. So when it's an IoT device with low power, that's easy maintenance. You don't need an installed base. It opens up a lot more applications for them. And I think that's very exciting.
So can we assume that we are closer to that utopia, that all my houses, all our houses will have all the sensors on the windows, doors, all the door shelves everywhere? Are we closing to that?
First, I would like you to answer, how many houses do you have? You said all my houses.
No, all of us. The houses of all of us.
He's a lucky guy.
No, I have one.
No, I think it'll get there. But I think it really depends on the geography that we're talking about. I think in many of the emerging markets, the issues they're solving is the water level at the place where it should be? Or is the movement of farm animals in agriculture applications progressing how it should be? But I think from a sensor standpoint, yes. I think the security companies are already implementing a lot of this technology, but we are also seeing a lot of push in retail. How do you reduce shoplifting? How do you inventory inventory control better? How do you automate some of that stuff? And since the business case over there is in volume and clearly defined, I think those will drive a lot of the non-glamorous, unspoken applications. And that's where a lot of the business growth is coming from. So.
Fantastic. Thank you, Erwin. I think it was a nice conversation. Thank you for coming once more. Please, a round of applause to Erwin Guy.
That's nice to do. Thank you.
Our next panelist in presentation will be by Mr. Frank Sarasi, Senior Advisor in SEP Communication, Cybersecurity, and Infrastructure Security Agency. So please welcome Frank to the stage.
Thank you. Thank you, Al. Oh, okay. Well, I'll say good morning, but we got a few minutes before lunch, so I'm just going to go to the highlights. Again, I'm from the CISA part of DHS. We have the responsibility within the federal government to, I guess I'll see how I can cut this short. Anyway, provide priority communications. And I want to share with the Wireless Broadband Alliance our current service and our plans going forward. Our tasking documents come from the White House as far as providing national security emergency preparedness. It's been a voice service for the last 20, 30 years. And this kind of gives you our charge to provide a capability to ensure communications under all conditions. And again, Department of Homeland Security is the one that's within the federal government that's responsible for providing the capabilities. I want to highlight here that we've been voice up to this point in time, and this directive now says expand beyond voice and go to data, video, and information services. And again, Secretary of Homeland Security. Now, all that we do is standards-based, and then we go to the FCC, and they provide the regulatory coverage. So we've have reporting orders that just came out last year, updated for the Wireless Priority Service, the TSP. So just quickly, what NSCP Communications and using the three roles of the president as chief executive, commander in chief, and head of state. The different departments and agencies have national essential functions that are assigned to them that come into play based on the situation, and that going across, they deal with industry, state and local population, depending on the situation. For an example, when the president declares a disaster, that kicks into play a lot of programs that assist, and communications is critically important in carrying those out. Similarly, in his role as commander in chief and head of state. So we've had again, everything we do is standards based, starting with ITU and then down through ADIS, regional. And so we've had a government emergency telecommunication service capability, a wireless priority service. Our next generation network priority services has really been going through that transition from circuit to packet. And the telecommunications service priority, TSP, that's a restoration capability. In fact, that's what was used to restore after 9/11. The circuits at Wall Street were restored in less than a week using the TSP, which really is a FCC program that we administer for them. GETS has been around for a good while. Use the calling card, accessible from any domestic or international phone. The wireless priority service really was requested within about 30 days of 9/11 to provide a wireless capability. So we started on 2G, 3G, 4G as we've transitioned through. And that's accessible by dialing a vertical service code on your phone, and then that activates the priority features. We really came up with a dialer app, so you just go in and hit your person you want to contact and hit WPS, and it automatically does that for you, either for GETS or it makes it simple for the user. Again, the next generation priority is where we've transitioned the priority from a circuit network to a packet network. So we initially had priority in the long distance core networks back in 2014 initially, then the wireless, we started in 2017, the first capabilities there on IP, and the wireline. What's in the planning stages now is really for the data, video, and information services. We refer to that as multimedia priority services in 5G and similarly in like the Wi-Fi Alliance and so forth. So in summary, it's like a subscription based, it's operator managed it. We use based on standards, it's on the commercial networks. And so now we see there's a growing need to, move into the Wi-Fi networks. So GETS has been, landline based, cellular based for WPS, and now wireless through Wi-Fi. Our user base is federal government, state and local, tribal, territorial, industry, and other authorized users such as the Red Cross. So you just go through the access authorization process and you'll be provided with enhanced routing and priority treatment. We interoperate with the defense switch network, the satellite networks that you see here, all of the embassies, so forth. And we really want to now bring Wi-Fi in as part of this operational concept. Other countries have priority services that you can see here. Just highlight our wireless service providers going across the top, and then the coverage going vertically. So you can see there are 4 nationwide carriers, AT&T and FirstNet and T-Mobile, Verizon Wireless, and then we have regional carriers, US Cellular, C Spire, Claro, and Puerto Rico. And they've achieved a full operational capability now with voice over LTE on the first 3, and within the next year we'll finish up with US Cellular and Claro. So our future going forward now is to realize the next generation services for voice, data, video, information services over cellular, Wi-Fi, and wireline broadband networks, Cox and Comcast, Fios, Charter, Again, we've completed the core part. We're nearly completed the wireless part as far as the transition. So now we're trying to look forward to our next being able to allow NSCP users to roam seamlessly between heterogeneous access networks, cellular, Wi-Fi. We want to expand that Wi-Fi capability to the laptops and smartphones and IoT devices. And then our leadership is urging us expand that NSCP user base to 10 million subscribers by 2033. So that's kind of our vision going forward. I think we've heard all the reasons why Wi-Fi is really where you have to be. And so I don't have to, there's so many places where you get Wi-Fi, you can't get anything else. So we started in that direction probably about 4 years ago by going to the IEEE, and we have specified the priority access capability in 802.11be. And you heard Dorothy say that it's mature, it's available for purchase. It'll be finalized in 2024, next year. And we went to the Wi-Fi Alliance, and they've included this. Just a little shift in names. The international body said you can't use national security and emergency preparedness. So we said, all right, we'll call it Emergency Preparedness Communication Service. So that's what we're calling it in the IEEE as well as in the Wi-Fi Alliance. So that's part of the Wi-Fi 7 program. So going forward, we need to have the availability of certified Wi-Fi 7 products that support the capability. Then we need to prepare the readiness in the service providers so their Wi-Fi ecosystem will be able to provide end-to-end priority. And we're currently working on solutions for priority access on Wi-Fi and roaming, and that's on the work plan with the Wireless Broadband Alliance. And so our next step are to work with WBA to realize goals of seamless priority access over Wi-Fi networks, and that will allow us to meet our mission requirements and spelled out in the executive order. So there's where additional information can be found. My contact information is here, so I'm open now to any questions. I think we're almost back on schedule for lunch, so I'll be glad to answer any questions as you may have.
There's one here.
Yeah.
Implemented the latest version of NSA protocol-free encryption device on our Wi-Fi network. Just wondering, is that part of the standard that you're going to be adopting as well?
I'm more kind of on the planning and program side, and that level of technical details as others are handling that. So I'm going to have to I'm almost pass on that one, I'd say. But thank you. Appreciate it.
We have another question.
Hey, Frank. Yeah, great presentation. Question on who identifies and who authorizes, and what's your view about how that looks like in Wi-Fi? Because obviously in cellular, the cellular operator is able to authorize, and I think the SIM cards have access classes to identify emergency services, security services, and the like. So is there a view that there is going to be a central entity that authorizes all of these access from a Wi-Fi perspective?
I think what you're saying is how are we going to go through an access process on the Wi-Fi, and we've been working with the carriers, and that's why it was good to come here, because we want to end up with kind of a single solution and not a bunch of things to make it simple for the users. So at this point in time, we have like a proof of concept that's being developed by one of that'll be demonstrated a little further down the line. So that's our next, standards, requirements. That's our next step, is to get into that, how we can do that, simply.
So your view is that it's going to be a converged identity. So whether they're accessing EPCS like services over 5G or Wi-Fi, it's a common identity that they can move between those networks.
Yeah. Yeah, I mean, we've been, making Wi-Fi calls on our phone all along, and now to do that with priority, so you're already in the database. So we know you're. I mean, typically we have an access class to a cell phone that gives you that capability. So on a cell side, you're already really there. The service knows that, and now we have to do something similar on the Wi-Fi side, and that's what we're working on.
Okay, got it. Thanks.
Sure.
Are you also working with the FirstNet Authority on any of this and any task orders? I come from AT&T and I'm very familiar with the FirstNet program. And so obviously know from the cellular side as well as the Wi-Fi. So just curious if you guys are kind of coordinating together with that.
Yeah, I couldn't, I think you were talking about in case of FirstNet.
Yeah, so for the FirstNet Authority.
So we, work really closely with AT&T, and they've kind of harmonized the wireless priority service with FirstNet. So, their features of priority of, kind of came from that initial work. So we share our director and our ECD is on the board with FirstNet. So we share that information, fairly closely. So I think you're going to get the best of both worlds.
Gotcha. And I may just share your information with some of our folks that are on the FirstNet side as well. So thank you.
Okay, sure.
Thank you, Frank.
Okay, let's go eat then.
Thank you, Frank, for the presentation and CISA joined WBI and wants to be active on this area in the alliance. So good to see. So I just want to close the event. So I want to start by thanking once more all the sponsors that made the event possible and support it. As you can imagine, has been a fantastic week for us. We celebrated our 20th anniversary. We did some recognition awards to many of the members and most active individuals and companies in WBI. We celebrated World Wi-Fi Day and we had this wonderful congress yesterday and today. So I want to thank you all for being part of this milestone of WBI. I want as well just to highlight our next event of the year. So by October, we are going to have our members meetings and Wireless Global Congress from EMEA. Will take place in Paris on the week of the 23rd to 26th of October. This event is going to be co-located with Network X, just like we did last year. We co-located with Network X in Amsterdam. This year, we are co-locating with Network X in Paris. So if you have a chance, please plan your trips, plan your calendars to be available to attend our event in Paris. With this, and before I close to go for lunch, the session in the afternoon is going to take place at the Boingo Innovation Center. So the Boingo Innovation Center is just outside the hotel. If you look in front of the hotel, there is a monorail station. So the office of Boingo is right on that station. So you just need to go up the escalator. As soon as you go up the escalator, you will see the office of Boingo. Will be some of my colleagues anyway will be there to help you. We have as well, by the way, it's a very short walk. It's a 2-3 minutes walk. But we have a minibus available. If any of you would like to prefer to go by car, more than happy to help you on that. But I will walk. It's a very short walk. We have been here on this hotel for quite a long time. So I think a walk outside will always feel good. Lunch is here on the hotel. So will take place outside on the room on our side. And with this, I will invite you all to have lunch and see you in the afternoon at the CTO Group Innovation Forum at the Boingo Innovation Center. Thank you, everyone.